Matlab. I welcome all the participants in the studio with me and all the remote centers connected to us through ICT. Now, before we start with the program, let me introduce all the centers. First, we'll go to Panipat Institute of Engineering and Technology, Panipat. Dr. Gaurav Kumar. आप अपना माइक ऑन करिए डॉक्टर गौरव कुमार, आपका माइक ऑफ है शायद.
Hello.
Yes, please.
Hello, sir. Good morning.
Very good morning.
Hello, sir. This is Panipat Institute of Engineering and Technology, Matlab.
हेलो, आप स्पीकर अपना बंद.
This is Panipat Institute of Engineering and Technology, Matlab.
Yeah, welcome. How many people are expected to join attend this program? How many?
22 to 23.
22. From which discipline? From which areas of engineering?
Mechanical, electronics, IT, computers, business support. Interdisciplinary.
Okay, welcome once again. And please please ensure that people attend this regularly, because we are going to have some experts from outside so that people benefit from the program.
Okay, sir.
Thank you. Next, we'll go to Bhagwan Mahavir Institute of Engineering and Technology, Sonipat. Professor Pradeep Tyagi. Mahavir. Hello. Professor Tyagi is there? So welcome, Professor Tyagi. I see only 5-6 persons sitting in your hall. Okay, would you like to say something? You are not audible. Just switch on your mic. आपका माइक सही नहीं है, सिस्टम सही नहीं है. We are not getting the audio from you. या तो लैपटॉप चेंज करिए, नहीं तो इंटरेक्शन नहीं हो पाएगी. वन वे कम्युनिकेशन हो जाएगा ये. Okay, thank you for joining. Next is RVR and JC College of Engineering, Guntur.
Good morning, sir.
Very good morning.
I'm Dr. K. Ravindra, Head of the Department of Mechanical Engineering.
Welcome, Professor.
Sir, total 46 faculty registered, sir.
Hello.
46 members registered, sir.
How many? 46?
46, yes, sir.
That's great.
26 from mechanical engineering and remaining 20 from other disciplines.
Welcome, because this is an interdisciplinary program.
Yes, sir.
All people, engineering and non-engineering, can also attend this program.
Okay, sir.
Did I visit your college sometime?
Yes, sir. Mr. Pabla has visited, sir.
I am Dr. Pabla only.
Sorry, sir. I am Ravindra, sir, mechanical engineering HOD. You have
I did come to your college in Guntur.
Yes, sir.
Yeah. How is the college going on?
Very good, sir.
Okay. Welcome to the program.
Thank you, sir.
Okay, thank you. We'll go to the next college. Sobha Sharia Engineering College, Sikar.
सर माइक ऑन कर लीजिए
अपना माइक ऑन करिए. सुधीर कुमार राठी. Dr. Sudeep Kumar Rathi is there?
Hello.
Hello.
Hi, sir. Good morning.
Morning. I see very few people. 4 persons sitting in the hall. 5. Now it is 5. Was it Rathi?
सर माइक ऑफ हो गया.
आपका माइक ऑफ हो गया है. ये आप ले लो फाइल कवर. एक ले लो. सबको दे. Mr. Rathi, we are not getting you. Audio. We are not getting. चलिए, please ensure that there are more persons in the classroom and all of them attend the program. We will go to the next college, PVP Siddhartha Institute of Technology, Vijayawada.
Good morning, sir.
Very good morning.
This is Raghuram from Mechanical Engineering Department, PVP SIT.
This is Professor Raghuram.
Yes, sir.
Professor, how many people are supposed to likely to attend?
Sir, we have 20 registrations until now.
Okay.
So we are expecting 2 or 3 more.
They are all from mechanical?
No, sir. 15 are from mechanical.
Okay.
So we have 2 from IT, 2 from CSC.
Okay.
And 2 people from EEE also calls. So they are attending.
Because this is an interdisciplinary type of program, we will not concentrate on, because this is being coordinated by mechanical, so we will be talking more on mechanical, but it is an interdisciplinary program.
Yes.
Any engineering and non-engineering people can attend. All engineering and non-engineering people can attend this program.
Okay, sir.
Huh?
Okay.
Professor Raghuram, please ensure that people attend these sessions. Okay.
Yes, sir.
Okay. Thank you for joining. Thank you. Then we go to Shahid Bhagat Singh State Technical Campus, Firozpur.
Yes, are you able to listen, sir?
Yeah, I'm getting you.
Yeah, good morning, sir.
Very good morning.
How are you?
I'm fine. Kaun hai? Who is there?
Yes, sir. We have participants around 55 participants.
55 participants. That's very good.
Are you able to see my snap?
Oh, I'm not getting your photo. No, it is there.
Are you able to see now me, sir?
No. Now I'm getting you.
Right.
Yeah. So please be ensure that people attend the program, all the session.
Definitely, sir.
Right. Thank you and welcome.
Please, I would like to invite our director, sir.
Okay.
Please wait, sir.
Yeah.
A very good morning to you, sir. Sir, I am Dr. Hello, sir. It is audible?
Yeah, it is audible, ma'am.
Okay, sir. Sir, I am Dr. Rajni, Professor Electronics and Communication from SPS STC. I'm the coordinator of the course. So, sir, we have around 50 plus participants, and we have our director, Dr. T.S. Sidhu, with us. So, this is the actually first course on ICT-based course on optimization using Matlab. So, I think in our college it is being conducted first time. So now I request our director, Dr. T.S. Sidhu, to say a few words about the course. Please, sir. Yes, sir.
Dr. Sidhu, I welcome you to this program and
Good
thank you
morning,
for
good morning.
joining us. Very good morning.
Happy to see you organizing such kind of programs. Actually, this is the first time we are organizing this program in our campus online. Usually, we are having a number of programs through Netter. So, I wish all the best to your Netter as well as to our campus for organizing such type of programs. And I think this is the best facility for the teachers and for a kind of interaction with you people. And I do hope and wish that this should be a successful program.
Thank you, Principal Sir, Director Sir. We conduct a large number of programs through ICT mode, and this is the most economical and viable program because people do not have to move away from their institutions. And many people can attend at a time.
Yeah.
So, please keep connecting and taking advantage of these programs. Thank you very much. Thank you for joining.
Okay, welcome. Thank you.
Now we go to Suresh Gyan Vihar University, Jaipur.
Hello.
Hello.
Sir, good morning.
Very good morning.
How are you, sir?
I'm fine. How are you?
Fine, sir, fine.
So how many people are expected to be there?
Approximate 30, sir, 30.
30%. Okay. And they are all from which departments?
From all departments, sir, mechanical engineering, electronics engineering, computer science, and electrical engineering.
Okay, good. Very good. So communication seems to be good with you, audio as well as video. So please keep connected and ask your faculty members because now you do not have classes to attend all the sessions. Thank you very much.
Okay, thank you, sir. Thank you.
Then next is Mahavir Swami Institute of Technology, Sonipat.
सर माइक ऑन कर लीजिए अपना स्क्रीन से.
माइक ऑन कर लीजिए. डॉक्टर संजय कुमार हैं. Hello.
Good morning, sir.
सर इधर से तो ऑन है इधर से.
Hello.
Hello, good morning, sir. Hello, good morning, sir.
Timetable की कॉपी लेके जाना. Very good morning.
हेमंत बाबू है अभी मैकेनिकल इंजीनियरिंग.
Timetable. है इसमें timetable का. Timetable है इसमें. Hello.
Good morning, sir.
Dr. Sanjay Kumar, we are not getting you.
Sanjay Kumar sir is in campus only. You will attend 2 or 3 minutes.
आपकी माइक की प्रॉब्लम है कुछ.
सर लैपटॉप से बात कीजिए, एक्सटर्नल माइक से.
एक्सटर्नल माइक बंद करके लैपटॉप वाले माइक से बात करिए.
Hello.
हेलो.
Yeah, good morning, sir.
वेरी गुड मॉर्निंग.
It is Hemant Upadhyay, AP Mechanical Engineering.
तो कितने लोग अटेंड करेंगे?
It is 25 to 30 expected, sir.
35.
25 to 30.
25 to 30. चलिए please ensure that people attend the program.
Yes, sir.
Take benefit. I have around 10 persons in the studio also with me. I'll request them to introduce themselves briefly, your institute, your discipline. You can start from this side.
I'm Roma Singh from IT University, Hyderabad, and I'm from Mechanical Engineering.
Welcome. What is your good name?
Roma Singh.
Roman.
Yes, sir.
Roma.
Yes, sir.
Okay, good. Welcome.
Hello, good morning everyone. My name is Vikram, and I'm working as assistant professor in MIT Moradabad, that is Institute of Technology, Mechanical Engineering Department since 2012.
So it's from MIT Moradabad.
I'm from Maharashtra Institute of Technology, Aurangabad, Maharashtra. I'm working here as assistant professor and presently processing my PhD.
So one participant from Aurangabad, Maharashtra, all the way. He has come. Thank you. Thank you for joining.
Good morning, sir. Good morning, all. I am Varun Srivastava, and I'm working as an assistant professor in Bharatiya Vidyapeeth College of Engineering, New Delhi.
Bharatiya Vidyapeeth College of Engineering, New Delhi. Thank you. Thank you for coming.
Good morning, sir. Good morning to all. I'm from Government Polytechnic College of Mandre, Rajasthan. I'm from Mechanical.
Okay. One person from, one professor from Government Polytechnic, Hanumangarh, Rajasthan.
Good morning, sir. Good morning to all. I am KC Rai, Head of Department, Mechanical Engineering, Government Polytechnic.
So one more participant from Himachal Pradesh.
Good morning. My name is Vivek Sherpa. I'm here in Research Fellow in Terminal Block Research Laboratory with DRDO, Chandigarh.
So from TBRL, Chandigarh, a defense organization, we have a participant. Please sit down. Thank you.
Good morning, sir. I'm Rajiv. I'm from Lovely Professional University. I stay as a head of department in academic profession and assistant
Head of Department of?
academic profession.
Okay. Good. Welcome from Lovely Professional University.
I have PC, Mechanical Engineering Department, LPU Jalandhar.
So two participants from LPU Jalandhar. Thank you. Thank you. So from the participation and from the list of centers which we have connected, there is a widespread coverage of this program in the studio as well as through remote centers. I'm sure that we will be able to tell you something new and useful during this 5 days program. I don't know whether you have the copy of timetable or not there at your place. Otherwise, we will send you by email. We have sent? So we will send you a copy just after some time. So today being Monday, we are starting, and the first session after tea will be on Introduction to Optimization Techniques. What is optimization? How do we classify what is important in optimization? What are the applications of optimization? That we will cover. That will be taken by me. Next, in the afternoon, so the schedule will be that we will start around 10 o'clock every day morning. 10 to 11:15 will be the first session. Then tea break for 15 minutes. 11:30 to 1 o'clock, second session. Then lunch break for 1 hour. And 2 to 4 p.m. third session. Because many of the engineering colleges close at around 4:15, 4:30. So we also close at 4 o'clock. We stop the, otherwise our office timings are up to 5:30, but the course will close at 4 o'clock every day. Tomorrow on Tuesday, morning session will be taken by Professor K.C. Lachwani. He is our faculty only in mathematics. He will talk about simplex method, and in the second session, he will discuss the assignment problems with you. Then we will come to Matlab. That will be taken by Dr. S.S. Dhami, Introduction to Matlab, how Matlab actually works, basics of Matlab. Basics of Matlab. We will that will be discussed, that will be covered by Dr. S.S. Dhami. Then on Wednesday, we have a full first half on multi-criteria decision-making problems to be covered by K.C. Lachwani, Dr. K.C. Lachwani. Then second half will be again taken by Dr. S.S. Dhami on Matlab programming for optimization. Introduction to optimization toolbox, because if you are familiar with the Matlab software as it is, there are many, maybe 35, 50, 40 toolboxes dedicated to different applications. There are at least two toolboxes which are dedicated to optimization only. There are many other, like digital signal processing, many specific application-based toolboxes are there, which we are not going to cover. We will only touch the optimization toolbox. So we have tied up with Matlab people themselves. They will discuss the introduction to optimization toolbox, then how to use that toolbox for solving optimization problems. That will be covered on Thursday. First will be solving linear problems using Matlab, then solving non-linear problems using Matlab. We are trying to cover fuzzy logic and GA also, GA approaches in optimization. That will be on Friday. In addition, we have contacted ANSYS people. ANSYS is basically a FEA software, finite element analysis software, but that is also used for optimization of the systems, optimization of systems. If we are successful, we will have one session by ANSYS people also. We will adjust somewhere. So Friday afternoon, we may continue in this 2 to 3. After that, we will have the closing session. Now we will have a 10 minutes break. We will have 10 minutes break. You can have tea. Then 11:15, we assemble back so that my participants, that they have come from far off places, they will also have a cup of tea with us. So 11:15 we will assemble again and start the first session. Please be there at 11:15. Thank you. We'll have tea.
Okay, sir. Thank you, sir.
Thank you. Let's go and take tea.
सर फैकल्टी को बोल दो सभी को, यहाँ कोई नहीं है, टी ब्रेक हो गया ना एक्चुअली इसलिए।
ठीक है, ऐसे पूरा वो ना अर्थिंग की प्रॉब्लम है सारे, वाइब्रेशन सी फील होती है। ये सर को ये अर्थिंग की वजह से आ रहा है एक्चुअली, जो हो गया अर्थिंग होती है इसके में, जैसे इलेक्ट्रिक बटन से हटाऊंगा ये साफ हो जाएगा अपना। ये देखो लगाया अर्थिंग की वजह से बिजली जो खाई
हेलो बेटी
मोबाइल हो रहा है
अरे वो नोटिस कहाँ है? उसको साइन करवा दो। वो मिला ही नहीं वहाँ पे फाइल में। मुझे दोनों फाइल में सर्टिफिकेट नहीं देते। बैंक की वाले देखते हैं। कभी तो दो जगह ना किसका? जितेंद्र सर का है। जितेंद्र सर है ना तो और कौन है? राहुल राहुल सर का नंबर होता है नंबर
मेरे वाला किधर से काम कर ये अभी इंटरेस्ट है लाइव
हाँ नहीं व्हाट्सएप नहीं मेरे पास अभी सब छुट्टी है मीटर वाला है वो हेलो
इसकी मूवमेंट देख लो
99291 34374 ठीक है
हेलो 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 हेलो
अभी नहीं गए दूरी कर रहा था वो कौन कर रहा था
ये लोग कोई कॉलेज है क्या ये ये साइड में बारो का इंजीनियरिंग एंड टेक्नोलॉजी हाँ वही होगा टी ब्रेक
सर आपको आईडी कौन सी चाहिए? सर आप आईडी लिख लो, NA ट्रिपल दिया।
हेलो तो नहीं भी जाऊँ चलो फॉर्मेलिटी करना है तो गाड़ी होगी तो सरा वगैरह करना होगा फॉर्म वगैरह चलो करना होगा तो गाड़ी उसको गाड़ी बना लूँगा हाँ आपके तो गाड़ी होगा तो बैठा हो तुम्ही कोणते गाडी तुम्हाला दोन गेलो आलो म्हणजे गाडी तिला जा करून सांगितलं
लॉगिन कर लीजिए और मैं आपको एक क्वेश्चन करती हूँ gmail.com के डिवीजन लॉगिन gmail.com को लॉगिन कर दीजिए पासवर्ड वो रिक्वेस्ट आएगी कॉल भी कर दीजिए एक बार लॉगिन कर दीजिए
हेलो
Please put on your mobiles on silent mode, please.
हाँ चलिए
All centers are there. So welcome back to this first session on optimization, which is basically introduction to optimization. Now,
F5 प्रेस कर लीजिए सर तो ये रहने
F5 कर दूं?
बस हो गया
Now let's see what is optimization. Optimization, we normally talk about optimization in daily use, daily life also, day-to-day talk also, and we as engineers have special significance of this word optimization. We normally say that we have to optimize the resources. So what is the meaning of that? Optimization is basically a mathematical term in terms of some equations and all. But what we talk is, we will talk about engineering optimization. Engineering optimization is basically optimizing the resources to get the best results where more than one variables are affecting the outcome. Right? Now let's say, take an example. Let's say you have a new plant coming up, new factory coming up. You want to arrange the equipment in the plant. Now what I want to do, I want that there should be a minimum movement of parts from one machine to other machine. The distances traveled should be minimum, or the time taken to travel should be minimum. Or I want to optimize the sequence of operations on a component so that the throughput time for manufacturing that component is minimum. So that, because I'm from mechanical, so I'm giving a mechanical example. Let's say you want to arrange the, let's say you have a CPU, you have a microprocessor in the computer. You want to arrange the components in the microprocessor, I chip only. So it is similar to our plant layout situation, where you have a large number of components and you have a limitation on space, where you want to minimize the some criteria, or you want to maximize some criteria. So optimization is basically a combination of some resources, some input factors to maximize or minimize the output. That is the engineering definition what I have. It may not be a textbook definition, but it is practically what we want from optimization. Because you are from different disciplines, you can have different examples in your life, in your day-to-day working. I want to optimize the expenses in my household. What are the items I want to buy so that I can minimize the expenditure. At the same time, my requirements should be met, not at the cost of my requirements. Now, what are the basic criteria which we normally want to minimize or maximize? Let us talk from a mechanical point of view. When we are manufacturing a component, there are so many things which are going as input to the making a product. You take a washing machine. There are so many components which are going into the washing machine. Or let's say you are making washing machines. You are making in a single factory, you are making number of appliances. Now what should be the combination of, what should be the quantity of each appliance so that your profit is maximized? I want to maximize my profit, but there are different types of products I am making in the company, in the factory. Each is contributing differently to my profit. Let's say if a washing machine is made, I am making, let's say 5,000 rupees per machine. I make ceiling fans also. I make table fans also. Maybe I make some motors also. So what should be the combination? Now one very simple solution will be that I make the components only those products which are giving me maximum profit. Washing machine is giving me maximum profit per component, per unit of product. So one solution is that I make only washing machines. But that is not desirable. I have a constraint, because in the field of ceiling fans, table fans, motors, I do not want to be out of the market. So what I have, I put a constraint that okay, minimum 300 ceiling fans I should make. Right? I don't want to go out of market in any particular component, because Today, my washing machine is selling. Maybe tomorrow there will be a lot of demand for ceiling fans. And I have invested into ceiling fan equipment, manufacturing of ceiling fan equipment. So I do not want to go out of market in that particular product. I want to continue making all the products. But at the same time, I want to maximize the profit also. So what should be the optimum combination? What should be the optimum combination of the products or the components which I have to make so that I meet the minimum requirements? I don't go beyond the maximum limit also. Let's say I cannot maybe sell more than 10,000 washing machines in a month or in a year. So I should not produce more than 10,000 washing machines. But my production capacity is there. Spare production capacity will be there. So that means I should produce something else. What should be produced? Where my profit should be maximum. That can be one criteria. Second can be that my cost should be minimum. Right? So I have to decide. What I normally say is that optimization is basically a mathematical solution. It is a mathematical solution where you try to minimize or maximize some output, some outcome. Now I have to decide. I have to decide what I want to maximize or minimize. Let's say I talked about plant layout. I want to minimize the distance traveled between the machines. Now, if you are familiar with mechanical engineering manufacturing processes, you are making many components on the machines. Same set of machines is there, and the operation sequence in each case will be different. Right? So that means if you are making a mix of components, the total time required or the total cost or the total distances traveled in each case will be different. So what I have to do? I have to find a solution. I have to find a solution where the total cost or the total transportation time is minimum. What should be the sequence? Because I have to manufacture different types of products or components. So I need to have a mechanism where I should know what is my target, what I want to do. Because we are all mechanical engineers, we are all engineers, I'll say. We do one problem that is a traveling salesman problem. What is that? You have a person, he has to cover a number of cities, maybe 4 cities, 5 cities. We have to, that is the simplest problem. Then we want to plan a sequence of his tour, of his travel, that the total time taken or the total distance traveled by him is minimum. That is a simple problem, simplest problem which we do. And there are mathematical solutions for this. We have all studied traveling salesman problem. So one is that we should be very clear what we want to do. What I am talking is that you want to minimize the cost, you want to maximize the profit, right? You want to minimize the production time, and you want to maximize the profit also. If you want to minimize the production time, maybe you have to use costlier machines. Instead of a conventional lathe, you have to use a CNC lathe. So there's a conflict. There's a conflict in this case. I want to minimize the production time as well as I want to maximize the profit. So these are called multi-objective. I have multiple objective now. I have two objectives which I want to fulfill. क्या क्या है? दो ऑब्जेक्टिव हो गए मेरे. One is that I want to maximize the profit. At the same time, I want to minimize the production time. But conflict है. Conflict क्या है? कि अगर मुझे प्रोडक्शन टाइम मिनिमाइज करना है तो मेरे पास जो CNC मशीन है उसके यूज करना पड़ेगा जिसकी कॉस्ट ज्यादा आ रही है मुझे. I am trying to minimize the time, but at the same time, I am increasing the cost of production. So what is happening? My profit is getting reduced. So we'll discuss over the week. We have full week where we'll probably come across these circumstances depending upon the expert who is from which field he'll talk. So let us see what is the formal definition of optimization. It says optimization is the mathematical discipline which is concerned with finding the maxima and minima of functions possibly subject to constraints. Now let us see. Maxima or minimum we have discussed. That you want to maximize something or you want to minimize something. Minimize means I wanted to minimize the distance traveled by a traveling salesman. Maximize, I want to maximize the profit in a particular situation. Then he says possibly subject to constraints. I have talked about a product mix where I said that given the liberty, given the freedom, I will produce only washing machines because washing machine is giving me maximum profit per unit of product. Per machine मुझे maximum profit है. So given the liberty, I will try to produce only washing machines. That means I can maximize my profit. जिस समय मेरे पास कोई कंस्ट्रेंट नहीं है, मैं जितनी मर्जी बनाता रहूं. बट कंस्ट्रेंट है मेरे पास. कंस्ट्रेंट क्या लगी मेरे पास कि 10,000 से ज्यादा नहीं बना सकता कि वो तो बिकती नहीं है उससे ज्यादा. I am not able to sell those more than 10,000. That means एक तो दो कंसेप्ट मैंने आपको इंट्रोड्यूस की. एक तो है अनकंस्ट्रेंट, यू डू नॉट हैव एनी कंस्ट्रेंट. सेकंड इज कंस्ट्रेंट. I have a constraint. I have constraint. What is the constraint? That I cannot produce more than 10,000 washing machines, but I have spare capacity in the plant where that means I need to produce more of other components. 10,000 की लिमिट लगा दी मैंने इसके ऊपर. And when I come to a optimal solution for this problem, maybe मैं 10,000 भी ना कराऊं, मैं 8,000 पे बंद कर दूं. So एक कंस्टेंट ये हो गई. दूसरी कंस्टेंट क्या हो गई? That I have to make minimum 300 ceiling fans. वो मेरी रिक्वायरमेंट है to remain in the market. So एक मिनिमम होगी मेरी 300, बट उसके बाद मेरे पास मैक्सिमम भी है कि 1200 से ज्यादा सीलिंग फैन नहीं बिकते मेरे. So I have to have a limit on minimum as well as maximum number of a particular type of product. Right? एक कंस्टेंट हम लगाते हैं. Let's say X1 is the number of washing machines, X2 is the number of ceiling fans. एक कंस्टेंट हम लगाते हैं कि they will be both non-negative. Non-negative मतलब माइनस क्वांटिटी नहीं हो सकती इनकी, क्योंकि जब मैथमेटिक्स से हम सॉल्व करते हैं मैथमेटिक्स तो हमें माइनस क्वांटिटी भी दे देगा अगर हम अनकंस्ट्रेंट छोड़ देंगे इसको. अगर हम उसको माइनस वाली कंडीशन नहीं लगाएंगे तो वो तो माइनस भी दे देगा. तो हमने एक कंस्ट्रेंट लगानी है कि नो, X1 एंड X2 आर बोथ नॉन नेगेटिव एंड नॉन जीरो. या हमने कंस्ट्रेंट लगा दी कि X1 इज ऑलवेज मोर देन 400 and X1 is less than 10,000. 400 से ज्यादा वॉशिंग मशीन बनानी है और 10,000 से कम बनानी है. दो कंस्ट्रेंट हो गई मेरे पास. Similarly, I can have constraints on the other inputs. So जो optimization है, it is basically a mathematical tool. Application is in engineering and non-engineering areas both. Now, before we can think of optimizing something, we should be very clear that what we want to do. किस चीज को मिनिमाइज करना, किसी को दो ही चीजें हो सकती हैं ऑप्टिमाइजेशन में, या मिनिमाइज या मैक्सिमाइज. First requirement is that we should be able to express the objective of our work in a mathematical form. Mathematical form. Mathematical form in terms of what? In terms of the entities which are affecting the outcome. अगर मैं वापस अपनी प्रॉब्लम पे जाऊं, प्रॉफिट कौन हमारा इफेक्ट कर रहा है? प्रॉफिट is being affected by number of washing machines made and number of ceiling fans made and number of motors made. So I should know how much is the contribution of each product on the profit of the organization, right? So that means I should be able to write that objective more than one factors affecting. तभी प्रॉब्लम बनेगी. अगर सिंगल फैक्टर है फिर तो बंद करते जाओ, वॉशिंग मशीन बनाते जाओ जितनी मर्जी, right? So unless we have it, then we should be able to write them in mathematical form. So if you look at this first screen, optimization is the mathematical discipline which is concerned with finding the maxima or minima of functions possibly subject to constraints. It can be applied in all areas. Engineering में मैंने बहुत कुछ cover कर दिया. All engineering areas. Architecture वाले भी करते हैं. Nutrition, you want to get the some outcome out of some food values. So what should be the proper mix? Civil engineering वाले करते हैं. Concrete strength है, right? When they design concrete mix, they have to decide what should be the components of the mix to get the, let's say, maximum strength, compressive strength. So they can decide. They can find out what should be the quantities of each of the inputs so that they get the maximum or the desired strength. Economics, transportation we had discussed. Now let's see what is this. The first thing we should know in optimization is that we have to write a function, we have to write a mathematical equation which we call it as objective function. Objective function is minimize or maximize what? Profit or something else. It can be, because simplest is profit and cost, right? But it can be anything else. Distance traveled, right? Time taken. Even in mechanical, we did a study on to maximize the tool life of a cutting tool, because there are so many factors which are affecting the life of the cutting tool. So you should be able to write that into a equation in terms of, let's say, cutting tool life is, let's say, T. Now it depends on what? It depends on depth of cut, feed rate, and RPM, cutting speed, or V. If I am not able to write the tool life in terms of these parameters, V, F, and D, I cannot solve. So what I do is I have to write a equation that, okay, T is V raised to power something, F raised to something, and D raised to power something. So I write an equation which is called objective function, which is a function of Objective function is a function of the variables which affect the objective function. जैसे tool life वाली example पे आ जाइए. I will write tool life, cutting tool life in terms of V, F and D, and they may not be affecting it in the same proportion. So I write, okay, V raised to power A, F raised to power B and D raised to power C. I want to find those values. Now I have written that objective function. So that means there is a function which is, there is a function of n variables, n means 1, 2, 3, 4, any number variables, which is affecting the objective function. Subject to constraints. Subject to some constraints. Now it is not always that you have a constraint, a set of constraints. But let us see. It says minimize f of xy. That means there is a function which is dependent on, this is a, where x and y are the two variables which are affecting that function. And it says minimize fx y is equal to x square plus 2y square. That means there is a function fx is equal to x square and 2y square which I want to minimize or maximize, whatever. So I can write this like this. And x should always be greater than 0. There is no constraint on y. Y can be anything. But we have put a constraint here. So this is a constraint minimization problem. Just see this. Minimize. Minus 2 is less than x is less than 5. And y is equal to or greater than 1. So what has happened here? I have put two constraints on x here. There are two constraints. That means minimum value x can have is minus 2. Not even minus 2, it should be greater than minus 2. And it should be less than 5. So it has to be translated into two constraints. That means x is minus 2 is less than x and x is less than 5. And y is equal to or greater than 1. Or the third type, just see, x plus y is equal to 2. So that the sum of x and plus y should be 2, but there is no constraint that there should be positive or negative. Right? So what is the objective function here now? Objective function is minimize x square plus 2y square. Subject to what constraints? Constraints may be what we called as equality constraints, where you have x plus y plus is equal to 2, or inequality constraints where it is equal to, less than, equal to, greater than. Okay. Let's say we want to optimize the minimum of this function. Some function has been plotted. Some function has been plotted. So where is the minimum of this? So minimum will be the lowest point. But if you see this x-axis, there are 2 points which are below that point. Now let's say we start at left-hand side. Okay, let's say we start at the right-hand side of the curve. How the optimization will work? It calculates it gives some values to the variables x and y. Let's say we go to that previous equation. It will give the values to some values to the x and y variables and calculate the objective function. And it will increment the variables again calculate depending upon the criteria we have given. I'll talk to you about that also. It will give you the final results. So what happens here? There is something called termination criteria in optimization. So what is termination criteria?
When the optimization stops, whether it's
When the optimization will stop, right? Optimization will stop at a given criteria, which is given, which is we give as a user, we give, which is called termination criteria. So termination criteria can be difference between the two values of objective function. Let's say I am trying to maximize the profit. मैं कहता हूं कि अगर 1000 रुपए कम प्रॉफिट में डिफरेंस है, जो पहले सेट पे आया था, कुछ वैल्यूज हमने वॉशिंग मशीन और सीलिंग फैन प्रोडक्शन की निकाली थी, और जो नेक्स्ट स्टेप में अगर 1000 से कम डिफरेंस आया तो इसको टर्मिनेट कर दो. इसका मतलब है इसके बाद काम करना, बिकॉज व्हाट वी प्रेज्यूम दैट whenever you are working on the computer, that also cost is there. So minimize the working cost, analysis cost. हम कहते हैं कि ओके, जब 1000 से कम डिफरेंस हो गया तो टर्मिनेट दी ऑप्टिमाइजेशन प्रोसेस, और वो वैल्यू मुझे दे दो क्या है, x1 और x2 की, सीलिंग फैन कितने बनने चाहिए और वॉशिंग मशीन कितनी बननी चाहिए. So termination criteria can be the difference between the two consecutive values. If you have seen, if you have gone through the optimization process, it is basically an iterative process. Iterative process means it starts with some value, calculates the objective function, increments or decrements the values of the variables, या तो बढ़ाता है या उनको कम करता है, and it again calculates the objective function, and it goes on repeating. It is a iterative process. So एक तो है कि जब हमने दो वैल्यूज में डिफरेंस हमें पता चल गया कि इससे कम हो गया, अब डिफरेंस, अब 1000 रुपए से ज्यादा प्रॉफिट नहीं मेरा बढ़ रहा, तो मैं कहता इसको टर्मिनेट कर दो, चलो छोड़ो ठीक है. दूसरा है कि नहीं, मैं तो देखना चाहता हूं कि आगे जाके कितना होता है. मैं कहता हूं कि नहीं, जब तक मेरी 500 इटरेशन नहीं होती मैं इसको चलने दूंगा. सो आइदर इट इज नंबर ऑफ इटरेशंस, दैट 1 लाख इटरेशन, क्योंकि कंप्यूटर कर रहा है, मैं नहीं कर रहा, तो मैं कहता हूं 1 लाख इटरेशन होंगी तब तो उसके बाद बंद कर देना. जो भी वैल्यू आएगी मुझे एक्सेप्टेबल है, और उसमें से जो मिनिमम होगा वो मुझे दे दो. ऐसा नहीं है कि 1 लाख मेरा 600 के बाद मेरा x1 x2 की वैल्यू आई जो मिनिमम थी, उसके बाद मेरी बढ़ गई 1 लाख पे चला गया मैं, फिर बढ़ गई 1 लाख वाली वैल्यू नहीं मुझे चाहिए, मुझे तो जो मिनिमम वाली थी वो स्टोर करनी चाहिए. तो वो बता देगा कि ठीक है कि 650वीं इटरेशन पे मेरी वैल्यू इतनी आ गई थी, दैट इज ओके, that I will store, and that the system will give me that okay, these are the optimal values and this will be the profit at this optimal value. So termination criteria will be either number of iterations or the difference between two consecutive values of objective function. Now coming to this, अगर आप राइट साइड में देखें, एक जगह पे मिनिमम हो गया ये, है ना, लोएस्ट उस पे आ गया, तो जब लोएस्ट पे आ गया पॉइंट पे हमारा मिनिमाइज कर रहे हैं हम, लेट्स से ट्रेवल टाइम मिनिमाइज कर रहे हैं, तो यहां पे ब्रेक हो जाएगा हमारा ऑप्टिमाइजेशन प्रोसेस, ब्रेक हो जाएगा, बिकॉज इससे अभी नीचे नहीं हो रही वैल्यू, नीचे नहीं जा रही. बट इफ यू एक्चुअली सी, अगर आप लेफ्ट साइड पे उस लाइन को फॉलो करते आओ तो उसकी वैल्यू तो कम है, वैल्यू इज लेसर देन व्हाट द वैल्यू व्हाट वी हैव गॉट. सो देयर आर मोर देन वन मिनिमा हियर. द राइट साइड मिनिमा, it will depend which one will come first. If you start from left side, your initial values are starting from left side वाला मिनिमम पहले आ जाएगा. If you start from right side वाला मिनिमा पहले आ जाएगा. So let's say you start from right side to make these things clear. So right side वाला मिनिमा पहले आ गया, but it is not the actual minimum value. Minimum value तो left side वाली है, but the behavior of the curve is, behavior of the function is like this. So what happens? हमारा तो वहीं पे terminate हो गया system. So this right side minimum जो है value, that is called local minimum. You may have more than one local minimas. Whereas जो right side left side वाला minimum value है, उससे कम कोई नहीं है. आप पूरा function scan कर लोगे between the given range, है ना? Between the given range ही है ये भी, -4 to 4 ही है. So between the given range, there is no value which is lesser than the minimum value on the left side. So this is called global minima. We should be very clear that what is local minima and what is global minima. जब हम optimization use करते हैं, because many of you will be using this optimization for your research purposes. Maximum problem will be that you will be caught up in a local minima. How to get out of this? That is the biggest problem. You are held up and the computer gives the value and you know it is not the value. When you are searching something, you know what should be the value. Approximate value तो हमें पता ही होती है. So but you are held up somewhere. So the problem is how to get out of this. इससे बाहर निकलेंगे तभी ऊपर जाएंगे दोबारा. So we have to find out some ways of getting out of this. Either you take a sudden jump या आप इंक्रीमेंट बढ़ाओ. कुछ ना कुछ तरीका निकालना पड़ेगा. Okay, this is the mathematical treatment. We will not go into mathematical treatment at this point because I want to be on the practical side only. So what we have is, in optimization, what we have is, we have an objective function, we have set of constraints. Now, if the objective function as well as the constraints are linear. Linear means any of the variables doesn't have power more than 1. So it is 2x plus 3y or 5x plus 6y or 10x plus 10y plus 20z. Neither the objective function nor constraints, or we say objective function as well as constraints both are linear. That is called a case of linear optimization, right? That is called a linear optimization, for which simpler method which will be discussed in the afternoon, simplex is used for, or linear programming is used for solution of linear equations. If the equation is simple, we have been doing it. We have been doing graphical method of solution of two or three equations. Because the variables involved were only x and y, and we have two equations or three equations, so we could do it manually. But where the number of variables is, let's say, any number, n number, and maybe they are not always linear, it may not be possible to solve all these equations manually. So what has happened? So computer has come into picture, and computer has helped because of its faster solution capabilities. So जब जैसे जैसे complex होती गई problem, manually it may not be possible. People have been doing earlier, but number of variables बढ़ने से complexity of the system बढ़ने से computer has had. People have written their own programs. There are commercial programs available. Let's say in Matlab, you have an optimization toolbox where you have to do, what you have to do is you have to just give your equation and the constraints, your objective function and constraints, and it gives you the outcome. It gives you the solution. It gives you the optimal value as well as values of variables at that optimal value. So depending upon the complexity of the problem, you have to choose the tool. So one is that you have a linear programming problems, linear optimization problems, where the equations are involved in objective function as well as constraints are linear. If you have either objective function or any of the constraints or all of the constraints or objective function as well, एक भी या सारे या any number are non-linear. That means the power is of any of the variables in the equations is more than 1. It is called a non-linear optimization problem. And the treatment is different. Solution method is different. Right? Basically, this is a mathematical treatment, which when we talk about maxima and minima in mathematics, this is done at the first derivative and second derivative. So at local maxima or local minima, first derivative of the function is 0, and if second derivative of the function is more than 0, if it is less than 0, it is local maxima. So let us not go into this detail at this stage. Maybe somebody will discuss all this. Now let us see how the system works. Once you have written the objective function and constraints, what you do is you normally there are ready-made programs available, or if you are very good in programming, you can write your own program. People have been writing their own programs also. The advantage of writing your own program is that you have a better control on the working. I myself experienced this problem because sometimes you are stuck up somewhere in the program when you are using a ready-made program. What will happen? Sometimes the denominator will become 0. So division by 0 is not possible. So the program, either the computer hangs or the program terminates. But if you have written your own program, you know what is happening. You can always say that if denominator becomes 0, give it a small value. The program will never terminate. So people have been writing their own programs also. So what it needs is that you need to give a starting value. There are some techniques where starting value also the system will automatically find. But if you have an idea about a starting value, means starting feasible value. Starting feasible value क्या होती है? Where all the constraints are satisfied. If you say that x should be more than 3, x should be, and let's say you say x is more than 3 and less than 10, so x value should be between this, right? Similarly, y, z. Normally, when we have to write the program, we do not write x, y, z. We write x1, x2, x3 because it is computer is more convenient to work with these values, because you just write an array and put the values in that array. So you need a starting value, starting point, or starting physical point where you want to start. Then you want a convergence criteria. What will be by termination criteria? Termination criteria can be either the difference in the two consecutive values or the number of iterations. How many times the system should work, program should work. That I can give. Before that, I should define the objective function and constraints. Another parameter which I need to give is the increment value. It may have inbuilt increment value, but if possible, I should give an increment value that, okay, x variable, x1 variable, x2 variable, x3 variable, what should be the increment? What should be the increment in each value? Okay, एक value लेके हमने calculation कर दी, उसके बाद next value जब calculate करनी है, what should be the increment? How much x1 should be incremented? Whether it should be incremented or decremented. That who will decide? Probably that the program itself will decide. Sitting outside, we cannot do that. We have to give these three values, and rest of the things the program will do. It will give you it will do the iterations. It will check at each step. Let's say it will calculate the objective function and store it. It will increment the variables, calculate the objective function again, and compare it with the first value. So it can say, okay, this is the minimum value till now. So if the next value is less than the previous value, so it will store it as the minimum value. Again increment it, increment the variables, and calculate the objective function. Okay, this is just basics of optimization. There are many techniques which have been used. One is the classical techniques like linear programming, geometric programming. Any other programming techniques you have? You know it? Integer programming, dynamic programming. Okay, let's see. Classical optimization techniques, that means there are other optimization techniques also, which are modern techniques which decide in which direction they have to go. And they are not stereotype techniques. They will find out the next step themselves, right? We'll come to it. Let's say the classical optimization techniques are useful in finding the optimum solution or unconstrained maxima or minima of continuous and differentiable functions. One of the conditions in mathematics is that the function should be differentiable at that point. So I said we are not going into the mathematics at this point of the optimization. These are analytical methods and make use of differential calculus in locating the optimum solution. The classical methods have limited scope in practical applications, as some of them involve objective functions which are not continuous and or differentiable. Because we may have in practical applications, the function may not be differentiable at a particular point. Discontinuous functions also we may have. Three main types of problems can be handled by classical optimization techniques: single variable functions, multivariable functions with no constraints, and multivariable functions with constraints. Constraints may be both equality and non-equality constraints. These are the numerical methods. Linear programming. Linear programming will be only for linear optimization problems, where both the objective function as well as the constraints are of the linear type. Integer programming, where all the variables will take integer values. Decimal values नहीं हो सकते इसमें. Quadratic programming allows the objective function to have quadratic terms, while set A is a design variable space. Must be specified with the linear equalities and inequalities. Nonlinear programming studies the general case in which the objective function or the constraints or both constraints contain nonlinear parts. Even quadratic programming and integer programming are also nonlinear programming. इसमें भी quadratic में तो 2 power होती है, raised to power 2. Stochastic programming studies the case in which some of the constraint depends on random variables. Dynamic programming, as somebody said, studies the case in which the optimization strategy is based on splitting the problem into smaller subproblems. Combinatorial optimization is concerned with problems where the set of feasible solutions is discrete or can be reduced to a discrete one. Infinite dimensional optimization studies the case when the set of feasible solutions is a subset of an infinite dimensional space, such as space of functions. And constraint satisfaction studies the case in which the objective function f is constant and you manipulate the constraints. What is hill climbing? That means you go on incrementing. Is a graph search algorithm where the current path is extended with a successor node which is closer to the solution than the end of the current path. That means you calculate the solution, objective function, and if you are going in that direction where you are getting the better results, then only you extend in that direction. Otherwise, go in another direction. In simple hill climbing, the first closer node is chosen, where in steepest ascent hill climbing, all successes are compared. Anyway, hill climbing is a complete optimization area where you have number of variables, number of alternatives at each point. है ना? जैसे tree है, उसमें you have alternate methods, alternate paths available. So which path you should take? You do not know which path will give you the best solution. But you calculate the possible values along each path, and the path which is giving you better results, you follow that path. है ना? 4-5 ऑप्शन है आपके पास, 10 ऑप्शन है. So you try to go along each option. जो ऑप्शन आपको बेस्ट रिजल्ट देती है, which is taking towards your goal may be minimize or maximize. अगर उस डायरेक्शन में लेके जा रही है, उस डायरेक्शन में आप नेक्स्ट स्टेप लोगे. Simulated annealing, basically it is from the annealing process that you give a treatment or shock. Okay. Heating and controlled cooling, so not shock, controlled cooling. That means you take it to a point, then go down slowly. Please don't worry about all these terms, because you have to just know that these terms are available, because we during this week we will not talk about these terms again. We will restrict to Matlab based programming only, right? So because this is just to introduce, because you should know all these terms. In the simulated annealing method, each point of the subspace is compared to a state of some physical system, and the function to be minimized is interpreted as the internal energy of the system in that state. Therefore, the goal is to bring the system from an arbitrary initial stage to the state with the minimum possible energy. Possible energy means minimum possible objective function only. This genetic algorithm has been used very widely used. GA it is called. Very widely used, lot of research work has been done, and there has been very wide engineering applications of GA. It is called evolutionary algorithm. That means it evolves. It evolves. It is basically, it works on a child-parent combination, that good parents will produce a good child. So it takes a combination of the parents to the new value. They call it a child. दो parents की values की combination लेके उसकी एक नई next value बनाता है, right? A lot of work has been done. It is a very simple technique also. There are many variations in GA which has been discussed. So genetic algorithms are a particular class of evolutionary algorithms that use techniques inspired by evolutionary biology such as inheritance, mutation, selection, and crossover. Genetic algorithms are typically implemented as a computer simulation in which population of abstract representations of candidate solution to an optimization problem evolves towards better solutions. The evolution starts from a population of completely random individuals and occurs in generations. In each generation, the fitness of the whole population is evaluated. Multiple individuals are stochastically selected from the current population and modified to form a new population. That is what I said, child-parent combination. The new population is then used in the next iteration of the problem. That means from the previous solution, you take number of candidates and take their characteristics and start with a new solution, new set of variables. Another method is ant colony optimization. You see, these are nature-inspired methods. Nature-inspired means, if you have seen this honeybees, when they fly, honeybees, they fly, they take a particular route. Nobody has taught them optimization. Optimization has come from them. When they return to their colony, they take a particular route. Similarly, you can see that you have a flock of birds flying in the sky. Just see the shape of that flock. That will be aerodynamic shape. Least resistance. Least air resistance will be there to that. So nobody has taught them. We have learned. We have learned from them how to make a aerodynamic body. How to make aeroplane. आप देखना ऐसे ऐसे उड़ेंगे वो, है ना? So in the real world, ants wander randomly and upon finding food return to their colony while laying down pheromone trails. मतलब ये है कि they leave small particles in the air when they come back, and the next batch, next ant, honeybees will come only following that path. कहाँ से पता चलेगी? जो फेरोमोन पहले छोड़े हैं मक्खियों ने, उसी को फॉलो करके आए pheromones. If the other ants find such a path, they are likely not to keep traveling at random, but instead follow the trail laid by earlier ants, returning and reinforcing it if they eventually find food. Over time, however, the pheromone trail starts to evaporate, thus reducing its attractive strength. The more time it takes for an ant to travel down the path and back again, the more time the pheromones have to evaporate. The short path, by comparison, gets marched over fast, and thus the pheromone density remains high. What it wants to say is, every bee, when it comes back, leaves pheromones. जो longer path वाले pheromones हैं, that may not be traversed by other bees, so वो तो evaporate हो जाएंगे, but जो shorter path पे आएंगी bees, वो और pheromone छोड़ती जाएंगी, so that will be getting stronger and stronger. जो evaporate हो गया, that will not be visible, that will not be sensible to the ants which are coming afterwards. जो shorter route से आई थी उसमें तो कई बहुत सारी bees आ गई, तो वो वहां पे रहेगा, उसी पाथ से आएंगी दोबारा फिर सारी. So that probably that aspect has been used in ant colony optimization. Pheromone evaporation has also the advantage of avoiding the convergence to a locally optimal solution. If there are no evaporation at all, the paths chosen by the first ants will tend to be excessively attractive to the following ones. In that case, the exploration of solution space would be constrained. So this is a nutshell ant colony optimization. Now let us discuss a small problem. Let's try to wrap up. What is optimization? Optimization is that means when you have a combination of resources, and that is my personal view, that there should be a restriction on the resources. Resources should not be available in abundance. You have a constraint on resources. रिसोर्सेज क्या है? टाइम पे कंस्ट्रेंट है, प्रोडक्शन कैपेसिटी पे कंस्ट्रेंट है, आपकी जो प्लांट लेआउट के लिए या चिप लेआउट के लिए स्पेस है, उस पे हमारी स्पेस है, अपनी कंस्ट्रेंट है. सो व्हेन यू वांट टू हैव ए कॉम्बिनेशन ऑफ रिसोर्सेज टू मिनिमाइज और मैक्सिमाइज द आउटकम, दैट इज ऑप्टिमाइजेशन. और ऑप्टिमाइजेशन के लिए आपको you need to have a objective function, you need to have a set of constraints. Unless we are able to model it into a mathematical form, we will not get the correct results. The accuracy of the results will depend upon how accurately we have been able to model the problem into objective function. ज्यादातर क्या होता है कि अगर हमने ऑब्जेक्टिव फंक्शन हमारा प्रॉपरली रिप्रेजेंट नहीं कर रहा हमारे, यूजुअली तो सिंपल प्रॉब्लम्स मैंने की है, वी मे हैव कॉम्प्लिकेटेड इक्वेशंस रिप्रेजेंटिंग द फिजिकल फिनोमेना. अगर फिजिकल फिनोमेना को हमने मैथमेटिकली प्रॉपरली रिप्रेजेंट नहीं कर सके, तो वी आर नॉट लाइकली टू गेट ए वैलिड रिजल्ट व्हिच कैन बी फिजिकली यूज्ड. सो ऑप्टिमाइजेशन starts with the objective function, what we want to do. We should be able to decide and write it mathematically. We have been doing optimization graphically also, but that will be for very simple problems. Now we are talking about computer-based optimization. For that, we need a mathematical function. So optimization can be constrained and non-constrained. Optimization can be linear and non-linear, depending upon what type of objective function and constraints we have. Now we talked about global and local minima and local maxima, and we have to think, depending upon the situation, how to get out of this. This is very, very typical situation where you will be, many times you will be held up, that you will not be able to get out of your program may terminate, but you know you have not reached the global minima or maximum. Now I worked on a problem that is basically maximization of cutting tool life. I introduced it earlier also, that we had T is equal to tool life is equal to V, F and D raised to some powers. Now this becomes the objective function. Objective function is that maximize t, which is in the form of a equation v raised to power a, f raised to power b, and d raised to power c. Now, what are the constraints now? What can be the constraints? Constraints are that I have a limit on the v, or v I can convert in terms of pi d n. D is fixed, so I can convert v in terms of n RPM, which is controllable, directly controllable. So I have a limit on the RPM. So one of the constraints is that I can have minimum RPM of, let's say, 40 RPM and maximum of 4000 RPM. So I say, okay, n is more than 10 and n is less than 4000. Two constraints I have put on n. Similarly, I have put a constraint on f, feed rate. I can put, depending upon the material I have to cut, cutting tool material, machine availability, what is the machine I will be using, and what is the capability of the machine, what can be the maximum and minimum feed available on the machine. Let's say maximum feed available on the machine may be very high, but the recommended value for a particular cutting tool and work material may be limited. I can put a limit on that. So I can make constraints for this. Similarly, depth of cut, I can put a constraint based on the system integrity. जो machine है मेरी कितनी depth of cut ले सकती है. So these are the direct constraints I have put. V, F and D पे मैंने दोनों साइड पे minimum and maximum पे constraint लगा दी, linear constraints लग गई. But at the same time, I know that my depth of cut and feed do affect the surface finish. So if I can write a equation for surface finish in terms of F and D, or Fn and D, RPM, depth of cut and feed rate, that should also be satisfied, because maybe I need a good surface finish. I should need a surface finish limited by some number. इससे ज़्यादा नहीं होनी चाहिए मेरी surface roughness. So I write a equation. Let's say I say surface roughness is F square by F8D. Please don't take it. Just some hypothetical value I have said. That okay, that my surface finish F square by 8D should be less than 0.5, some value. That should also be satisfied, right? Then maybe there are some additional things. You have 10 machines available. I want the cost to be also minimum. Which machine should I select? There are 10 machines which are physically available in the factory, but 2 of them are out of order, or 2 of them are already loaded, which are not available. My system should not consider those machines at all. So all those factors can be taken and your optimization problem can be solved, which I did solve. There are different techniques which you can use, and this week we will concentrate on, in addition to linear programming, we will concentrate on how to use Matlab for solving optimization problems. Then maybe, if possible, we will have a session on ANSYS also. That should help all of you in solving some problems. Another thing I want to tell you here is that in 1 week, we will introduce you to solution of optimization problems through Matlab. If you keep working, if you go back and start working on Matlab at your places, then you will learn. Otherwise, I'm sure within 15 days, you will forget everything. So my session comes to end here now. Any questions you have? Let us have some questions.
Any question from any of the nodal center?
Huh? हाँ मेरे पास. Okay, Panipat Institute of Engineering and Technology. Speaker on है क्या?
Sir, no queries.
Just your slide.
Hello.
Bhagwan Mahavir Institute of Engineering and Technology, Sonipat.
Hello.
Hello.
Good afternoon, sir.
Very good afternoon, sir. बोलिए.
Sir, we have question.
No questions?
No questions, sir.
Okay, thank you. RBR and basic college. Guntur.
Hello, sir.
Hello.
Good afternoon.
Very good afternoon.
Sir, when there are multiple solutions, how to know when should be the global optimization coming?
It's not clear.
Multiple minimas are there, minimum or maximum values. Hello.
Come near to this computer, please.
Hello.
Hello.
Please come close to the system.
Hello.
Hello.
Yes, sir.
If multiple solutions are there.
Yes.
Hello.
Hello.
When you are speaking previously, you are told that there will be local minimum and global minimum, isn't it?
Multiple objective functions. You want?
Yeah, multiple function.
So we may talk. Otherwise, I'll come back during the session. Okay, during the period. Okay, we'll talk about multiple objective functions also. Okay.
Okay.
The only thing is we make a combined objective function by giving some weightage to the multiple objective functions. Then only we solve. We say, okay, objective function 1 plus objective function 2 multiplied by something.
No, not sir.
Okay, we'll come back maybe.
Regarding solution, I'm talking, sir.
We can solve that. We will come maybe during this week itself. I'll come back.
Okay, thank you.
Okay, thank you. Sikar Rajasthan, Sobha Saria.
Yes, sir. Good afternoon. Am I audible?
Yeah, audible.
Yes, sir. Sir, first of all, thank you. The session was very informative. And my question is about the hand cloning optimization.
Yeah.
Hand cloning optimization, is it related to our mechanical or not?
It can solve any type of problem provided we are able to model it correctly. It is very much applicable to mechanical engineering problems.
Okay, sir. Thank you so much, sir.
Thank you, Professor. Thank you. Vijayawada, PVP, Professor Raghuram.
Sir, no questions, sir. Thank you.
Okay, Professor Raghuram, thank you. Firozpur. Shahid Bhagat Singh State Technical Campus, Firozpur. Suresh Gyan Vihar.
Hello, sir.
Hello.
Sir, which version of Matlab will we be working
We have latest version also, I think 15. Which version you have, sir?
Yeah, I think I have 15.
15. So this will not have changed actually. This optimization toolbox has not changed.
Yeah, that was my next question. Matlab, will there be any add-ons
Because optimization will not change. That does not change. I think. It will
which toolbox we will be working?
optimization only. Optimization toolbox. First is the basic basic Matlab. How to write a program.
Okay.
Okay. Thank you. Mahavir Swami Institute, Sonipat.
The mic is off.
Please switch on our mic.
Hello, sir.
Hello.
Sir, I have a question.
Yeah.
Sir, can we solve nonlinear programming through hill climbing method?
From?
Hill climbing method.
Which planning?
Hill climbing method.
You see, non-linear systems will solve all your linear programs.
Oh, you said
right?
that.
But it will be unnecessarily using costlier resources for simpler problems.
Okay, sir.
Right? So we should go for the simplest method.
Okay, sir.
Okay, thank you. So thank you very much, and we are breaking a little early, but 2 o'clock we should be able to assemble back and start with the next session. Thank you very much. Now I have some questions from my audience in the studio itself.
Hello. 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 Camera बंद है.
ये बैठता है नहीं भाग जाते हैं। मैं कोई बैठता है नहीं भाग जाते हैं सर प्रोग्रामिंग के लाइव क्या चल रहा है वहाँ पे? प्रोग्रामिंग में ऐसी चीजें बैठ के करनी पड़ती है, नाम मानना पड़ता है, मोड मानना पड़ता है, 4 बजे तक छः बजे तक, रात के 12 बजे से लेकर 6 बजे तक मोड मानना पड़ता है। तब जाके आपका होता है। लाइव आया नहीं, अरे आ तो रहा है लाइव, जैसे ही निकाल रहा है। चलो नहीं ये रहा ना, अपने तो आ जाएगा फिर है ना ये आ जाएगा सर और चालू करेंगे। है तो सर आपके पास अभी डाल दो क्या बजे की बात है या कीजिए डाल दो सर क्या बजे की बात है क्या बजे ये खत्म होगा ना कितने बजे की ये चलो डाल दो। Yes, ma'am. Ma'am, again, तो यहीं पे पढ़ता हूँ
मैम अभी तक नहीं हुआ स्टार्ट। मैम कुछ आ ही नहीं रहा, ऑनलाइन तो है, लाइव भी है, बट लेकिन स्टार्ट नहीं हुआ।
अजय मार्कर चेक कर देती हूँ एक से।
जो रुचि जानती है फिर कौन सा रहता है रुचि को बेटा कौन है रुचि में डायरेक्टर की फिर दोस्तों की जो और एक चीज तो बच्चों के लिए अच्छा उन्हीं क्या तो किस दिन पता चला
हेलो यस गुड मॉर्निंग हाँ जी
ऐसे तो
सर आईडी कौन सी थी आपकी हेलो
अब तुमने कुछ वैसे तो अब तुमने पता नहीं वो कुछ नहीं पता है कि कैसे
सर एक बार आपको रिक्वेस्ट दोबारा भेज दीजिए देखिए आपकी आईडी कौन सी थी हाँ
देखना पड़ेगा। सर हमने एग्जॉस्ट किया और वो भी था आईडी से चेंज कर लो NA-TTR-EPH
ठीक है सर, नहीं सर वो काम से कह रहे थे कागज में बता दिए। ठीक है सर, थैंक यू सर।
हाँ जी सब आपको
A very good afternoon to all of you. Okay, so now we will discuss on very important criteria in optimization problems. So today our topic is linear programming, formulation and techniques. Basically in linear programming problems, there are two types of ways to solve the optimization problem. One is graphical method and second is simplex method. So today in this session, we will consider only graphical method to how to solve the linear programming problem by using graphical method. So basically linear programming is an optimization strategy used for solving the problems for maximizing or minimizing the linear objective functions subjects to linear constraints. Important is that if we have only linear constraints, then we can use the linear programming problems. So A linear programming problem comprises of constraints equations which may be equalities or inequalities. So in practical problems, whenever जैसे मान लीजिए हम कभी भी कोई भी चीज परचेज करने के लिए जाते हैं, तो सबसे पहले शॉपकीपर हमारे से ये पूछता है कि आपका क्या बजट है ना? क्योंकि मान लीजिए हमने कार खरीदने जाना है, तो सबसे पहले हमारे क्या कंस्ट्रेंट्स होते हैं कि भाई ये मेरा कॉस्ट है, इससे ऊपर मुझे कार नहीं लेनी, जहां मुझे ये वाला कलर चाहिए, ये वाला उसके अंदर फीचर चाहिए। तो ये जो हम अपने हिसाब से कंडीशंस बताते हैं, बेसिकली दीज आर डिजाइन वेरिएबल्स। ओके, सो जब हम डिजाइन वेरिएबल्स को एक किसी वैल्यू के साथ रिस्ट्रिक्ट कर देते हैं, वो हमारे कॉन्स्ट्रेंट्स बन जाते हैं, जो हम अभी आगे देखेंगे। तो लीनियर प्रोग्रामिंग से हम कई तरह की प्रॉब्लम सॉल्व करते हैं, जैसे ट्रांसपोर्टेशन प्रॉब्लम्स, जैसे डाइट न्यूट्रिशन प्रॉब्लम, लाइक इन्वेंट्री कॉस्ट प्रॉब्लम्स एटसेट्रा। सो अभी हम इसको देखेंगे कि आज के सेशन में हम ये चीजें कवर करेंगे कि सबसे पहले कि लीनियर प्रोग्रामिंग जो हमने देखा कि क्या होती है, दूसरा कि लीनियर प्रोग्रामिंग प्रॉब्लम को सॉल्व करने का प्रोसेस क्या है, कि उसके कौन से 4 स्टेप्स हैं जो हमें प्रॉब्लम को सॉल्व करने के लिए चाहिए होते हैं। तीसरा, कैरेक्टरिस्टिक्स क्या है, कि कौन सी हमारे पास इनिशियल कंडीशंस हो या कौन सी प्रॉब्लम किस टाइप में हो, ताकि हम उसको लीनियर प्रोग्रामिंग प्रॉब्लम को डील करके उसको सॉल्व कर सकते हैं। चौथा, कंपोनेंट्स, मोस्ट इंपोर्टेंट पार्ट, कि वो लीनियर प्रोग्रामिंग प्रॉब्लम किन किन चीजों से मिलके बनी है, उसके क्या क्या उसकी नॉमेनक्लेचर्स हैं, वो इसके अंदर देखेंगे। और लीनियर प्रोग्रामिंग मॉडल को सॉल्व करने के जनरल स्टेप्स क्या होते हैं। फिर उसके बाद ग्राफिकल सोल्यूशन, जैसे हमने बताया, आज हम सिर्फ ग्राफिकल सोल्यूशन से डील करेंगे सेशन में। और ग्राफिकल मेथड में एक्सेप्शनल केसेस क्या हैं, इसके अंदर 3 एक्सेप्शनल केसेस होते हैं। एक होता है कि इनफिजिबल सोल्यूशन, एक होता है अल्टरनेटिव सोल्यूशन, एक होता है अनबाउंडेड सोल्यूशन। तो उस केसेस में फिर हम कैसे सोल्यूशन निकालते हैं, और जनरली जो हम देखते हैं कि किसी स्टेटमेंट प्रॉब्लम को कैसे मैथमेटिकल मॉडल में कन्वर्ट करना है, वो भी हम प्रैक्टिस करेंगे। और उसके बाद कुछ 1-2 प्रॉब्लम्स हम सॉल्व करके देखेंगे। तो फर्स्ट ऑफ ऑल आपको बताया जैसे लीनियर प्रोग्रामिंग क्या है, किसी भी फील्ड के अंदर हमें कोई ऑब्जेक्टिव फंक्शन डिफाइन करते हैं, उस ऑब्जेक्टिव फंक्शन को चेक करना होता है कि हमें मिनिमाइज करना है या मैक्सिमाइज करना है। जैसे हम मिनिमाइज किसको करेंगे, कॉस्ट को करेंगे, है ना। हम मतलब कोई भी कंपनी ये चाहती है कि हमें मैक्सिमम प्रोडक्शन, मैक्सिमम प्रोडक्टिविटी मिले, मैक्सिमम एफिशिएंसी मिले इन रिस्पेक्ट ऑफ लो कॉस्ट। ओके, तो उसके लिए फिर उसको कई तरह से लेबर कंस्ट्रेंट्स हो गए, मटेरियल कंस्ट्रेंट हो गए, तो वो सारी चीजें इसके अंदर हम देखेंगे। तो नाउ what is the process for linear programming problem? First of all, we have to identify the problem ki either it can be solved by linear programming or not. So what is the requirement if we can solve the linear programming problem or not? Yes, participants who are present here. Objective functions and constraints should be linear, because if there is linear and the method which we are discussing today, that is graphical method, in this method we should have only 2 design variables. Okay, if there are more than 3 design variables, we cannot solve by graphical method. For that we use simplex method, that will be discussed tomorrow. Next, we formulate that problem into mathematical model. Okay, so because without mathematical model we cannot plot graphs. So next we solve the model either with graphical method or simplex method, dual simplex method, etc. And then we implement that model in a practical field. So these are 4 steps which we generally follow to solve the linear programming problem. Next, these are the 3 important characteristics to solve any linear programming problem. First is objective function is of the minimization or maximization. Okay, there are no other third option. Either we have to minimize, either we have to maximize. Maximize हम क्या करेंगे, जैसे profit हो गया, efficiency हो गई, तो इस तरह से हम maximize करते हैं। और constraints हमेशा equality और inequality में होने चाहिए। ओके, लेकिन जो graphical method होता है उसके अंदर हम कौन से constraints लेते हैं? Yes please. ग्राफिकल में कौन से लेंगे, इक्वालिटी और इनइक्वालिटी? इक्वालिटी कंस्ट्रेंट्स हम जनरली नहीं लेते हैं, है ना, क्योंकि इक्वालिटी कंस्ट्रेंट्स में फिर हम रीजन को, शेडेड रीजन को, फिजिबल रीजन को नहीं शेड कर सकते, वो अब यूज करते हैं हम सिंप्लेक्स मेथड में, क्योंकि उसके अंदर फिर आर्टिफिशियल वेरिएबल्स, स्लैक, सरप्लस वेरिएबल्स ऐड होते हैं। तो ग्राफिकल मेथड्स में जस्ट हमारे पास इनइक्वालिटी का होना जरूरी है, either it is less than, either it is greater than. So third is all decision variables must be non-negative. This is most important condition कि जो ग्राफ हमारा है उसके अंदर हमें वही रीजन लेना है जो हमारा फर्स्ट क्वाड्रेंट में लाई करता हो। डिसीजन वेरिएबल नॉन नेगेटिव का मीन क्या है कि हमारे दोनों कंस्ट्रेंट्स किस क्वाड्रेंट में लाई करेंगे, फर्स्ट क्वाड्रेंट में, ठीक है। सो दिस इज द जनरल linear programming model. How we can write, we can see here, we have first objective function. In objective function, either we have to maximize or minimize. We will see the practical problems in next slides. So here objective function we generally represent it by z, means maximize x1 plus x2. We generally say we have to maximize the sum of two positive numbers x1 and x2, but we must have some constraints, subject to constraints, that x1 must be less than 5 and x2 must be less than 4. An example, we have constraints that x1 must be less than 5 and x2 must be less than 4, and most important constraint is x1 and x2 both are equal to and greater than equal to 0. Okay, x1 and x2 both greater than equal to 0. So in this slide we can see there are either types of variables, but in graphical we just take only two types of variables, x1 and x2, x or y, anything we can take. So these are three types: maximize, minimize, subject to constraints, and non-negativity constraint. So now next are the model components. Next are the model components which makes these are the parameters, these are the variables, these are the most important requirements which constitutes the linear programming problem. First is decision variables. Yes, what is decision variable? How can we define? Decision variables are those mathematical symbols which maximize or minimize the objective function. Okay, like we have objective function 4x1 plus 3x2. 4x1 plus 3x2. So objective function depends on what factors? x1 and x2. So because 4 and 3 are constants, so x1 and x2 are the factors which decides the objective function. Okay, so these are decision variables. So decision variables, जैसे हमने पहले भी एग्जांपल ली, मान लो आप गाड़ी खरीदने जाते हैं तो उसमें क्या होता है कि हम कंस्ट्रेंट्स लगाते हैं कि भाई मेरी कॉस्ट इससे कम होनी चाहिए, मुझे कलर ये मिलना चाहिए, तो ये कॉस्ट और कलर मेरे क्या हो गए? डिसीजन वेरिएबल्स हो गए. ओके, सो ऑब्जेक्टिव फंक्शन एक लीनियर मैथमेटिकल फंक्शन है जिसको हमें मैक्सिमाइज करना होता है और मिनिमाइज करना होता है, आइदर इट इन टर्म्स ऑफ प्रॉफिट, कॉस्ट, मैन्युफैक्चरिंग फर्म्स, प्रोडक्ट्स, एटसेट्रा. नेक्स्ट इज कंस्ट्रेंट्स. व्हाट आर कंस्ट्रेंट्स? जैसे हमने ये तो डिसाइड कर लिया कि डिसीजन वेरिएबल कॉस्ट है, मान लीजिए गाड़ी के लिए डिसीजन वेरिएबल कॉस्ट है, तो कॉस्ट की लिमिट क्या है कि मैं 4 लाख तक ले सकता हूं, 3 लाख तक ले सकता हूं. तो वो जो डिसीजन वेरिएबल की रेंज हो गई उसको हम बोलते हैं, जैसे हम इस केस में लिया था x1 लेस देन इक्वल टू 5. तो दिस इज आवर कंस्ट्रेंट कि भाई मैं 4 लाख से या 5 से ऊपर नहीं जा सकता, इससे कम मुझे कोई चीज खरीदनी है. तो कंस्ट्रेंट्स हर चीज में जरूरी होते हैं, क्योंकि अदरवाइज हम एक ऑप्टिमाइज किसी भी चीज को नहीं कर सकेंगे, क्योंकि किसी भी चीज की लिमिट नहीं होती. ठीक है. So next is parameters. Parameters are basically numerical coefficients. Basically numerical coefficients, like we can say 2x1, 3x1. So here the 4 and 3 are parameter and 2 and 3 are parameter, which are numerical coefficients, or we can say coefficients of decision variables in objective function and decision variables used in constraints. Clear? So next, this is the example we can see here. Here we have maximize z is equal to x1 plus x2. So this is called objective function. This is very layman. Objective function subject to these three constraints: x1 plus 2x2 less than equal to 4. Okay, first constraint. So in first equation, what are decision variables? Yes, x1 and x2. And what are parameters? 1 and 2. So what are constraint? Constraint is full equation, x1 plus 2x2 less than equal to 4. Okay, so in other types, 4x1 plus 2x2 less than equal to 12, minus x1 plus x2 less than equal to 1. And most important constraints is x1, x2 greater than equal to 0, because a line has no end. Okay, if we want to plot a graph like this line comes in fourth quadrant also, first quadrant also, and second quadrant also. So to bound our region, shaded region, so we have to consider that x1 and x2 must be greater than equal to 0. So we can construct a design vector. A vector constitutes with decision variables is known as design vector, and the x1 and x2 are the design variables, as we discussed earlier. So now we proceed to next things. Formulation steps to construct a mathematical model. First of all, as we discussed, we analyze the problem. Okay, what type of problem we are going to solve. So this is important, because in like we have to consider a transportation problem. Then what is our objective? In transportation problem, like we have to transport one material from one place of manufacturing to another place of requirement. So what will be our objective? Minimize time, minimize cost, and optimum route. Okay, so that we can cover maximum cities. Okay, so for that we have to first check that what type of problems we are going to consider. So first steps is analyze the problem and consider the objective function. Either we have to minimize, either we have to maximize. Second is determine the design variables. Okay, to minimize or maximize that objective function, which are the factors which influence that objective function. Okay, if we do not select the decision variable most appropriately, then our solution will not be optimized. Okay, so decision variables, so second step. Third step is variable bounds. Important. Variable bounds means, like we have seen here, x1 and x2, that each design variables have its own limitation. Okay, like x1, what x1 has limitation? That x1 should be less than equal to 5 in this case. Okay, and x2 must be less than equal to 4. So this is the lower bounds and upper bounds. Like we say, so this is lower bound and this 5 is upper bound, like x2. So what is the lower bound? 2. And what is the upper bound for x2? 6. So we select if we have a lower bounds or upper bounds, because this also reflects our shaded region. Okay, now fourth steps is whatever the constraints we have, which forms from decision variables, we will plot that all constraints in a graph. Okay, but whenever we draw the graph, we just normally consider the equation. We forget about the inequalities. We just take as that constraints as an equation. But when we will shade the region, then we will see it either its constraint is of maximization, either it is a constraint of minimization. Then last step is write the objective function and constraints in mathematical form. Okay. So now we can consider one problem. Please read this problem. And you should tell that what are our decision variables, what are our objective function, and what will be our constraints. Sorry. Mugs and balls are our design variables, okay? Because balls and mugs we have to produce so that we can maximize our profit, okay? So what are the constraints? Constraints are labor and material, okay? So labor and clay will be our material will constitute our constraints, okay? So how do we see? You can please construct the equations. What will be our objective function? Yeah. Yes, please. What will be objective function? Maximize Z is equal to, like we have 40x1, like we say bowl for x1 and this for x2. Basically labors will be considered as x1 because for making that part labor and clay. Labor x1, x2 is clay. Okay, so Z is 40x1 plus 50x2. Okay, you please note down this resource availability, which is not given in last slide, because only using that resource availability we can construct the constraints. Okay, but what is our limitation? What is our constraint? That in each day we cannot work more than 40 hours. Okay, total work of our labor we are considering here. And what is the constraint for clay? We can use at most 120 pounds of clay. Okay, LBS means pounds. Okay, so this is our constraint. Now we go to the last slide. Now you please construct the equation. For we can construct for labor first. Yeah, for labor, what is the labor constraint? Because to produce the mugs and balls, we have to consider that how labor and how material we have available. So for labor, what is the labor constraint? X1, 1x1 plus 2x2 must be less than equal to 40. As we have a resource availability, 40 hours of labor per day. Okay, and similarly for mug, now this is material constraint. What is material constraint? 4x1 3x2 less than equal to 120. Okay, and most important constraint, yes, yeah, x1 x2 greater than equal to 0. Clear to everyone? Okay, so these are our constraints. This is the final equation. Objective function we have 40x1 plus 50x2, x1 for balls or x2 for mug. Okay, so 40x1 plus 50x2 will be objective function, and x1 plus 2x2 less than equal to 40 is our first constraint for labor constraint. Okay, so now there are two types of solutions. One is feasible solution and second is infeasible solution. What are feasible solution? Feasible solutions are those solutions which solution does not violate at any of the constraints. Okay, like we have example in this case, if we consider x1 is 5, x2 is 10, we should incorporate the values of x1 and x2 in these equations. So Does these values violate any of the constraint? No, because if we put x1 is equal to 5 and x2 is equal to 10 in here, what is the value? 25. So it's right or wrong? Is it okay? Right. And this one is 70 less than 120. Is it also okay? Okay. So it means this type of mathematical model gives us which solution? Feasible solution. Similarly, if we take x1 is equal to 10 and x2 is equal to 20, so what are the values? First equation violate the constraints. Okay, value is 50 greater than 40. It means what type of solution will come? Okay, देखो जब हम x1 की वैल्यू 10 और x2 की वैल्यू 20 पुट करेंगे तो हमारे पास कंस्ट्रेंट की वैल्यू क्या आ रही है? फर्स्ट कंस्ट्रेंट में डालो 20 प्लस 2 इंटू 20 कितना आ गया? 40. Sorry, 50. 50 is less than equal to 40 or greater than equal to 40? Less, greater than. So it means this constraints does not match. So it means the type of solution which will give this problem is infeasible solution. Okay. So now we will proceed to our formal topic. This is called graphical solution of linear programming model. So there are two types by which we can solve graphical solution. First is isoprov, or we can say isoline method. Second is extreme point valuation method. Generally, we use extreme point valuation method. Okay. In generally, most of the times in the practical field, we use extreme point valuation method. So as I told you earlier, that to solve the linear programming with graphical method, how many decision variables we should have? 2. Because if there will be more than 2 decision variables, we cannot solve the model using graphical method. For that, which method we have to apply? Simplex method, or we can say dual simplex method. So we will start with, these are the 6 steps. You should note down, or you should understand. What will be the first step to solve the graphical method? You can read. First of all, we have to determine the problem along with the decision variable, objective function, and constraints. In nutshell, we can say that we have to construct mathematical model. What we have to do? If we have statement problem, we have to convert first into mathematical model so that we can proceed for our solution. Second step is mathematical formulation. Third is draw a graph. The constraints which we have obtained to maximize the objective function or minimize the objective function, we have to plot all the constraint equation on a graph. Okay. So according to the inequalities which is given in constraints, that decide our shaded region, or we can say feasible region. Okay. देखो हमने constraints की equation को तो ग्राफ में प्लॉट कर लिया, हम एग्जांपल करेंगे, उसको प्लॉट कर लिया, लेकिन कंस्ट्रेंट लेस देन इक्वल टू है और ग्रेटर देन इक्वल टू है, उसके हिसाब से हम ये डिसाइड करेंगे कि हमारा ग्राफ में रीजन कौन सा फिजिबल रीजन होएगा, क्योंकि 2 पार्ट होंगे लाइन के कितने पार्ट बनेंगे? लाइन पूरे प्लेन को कितने पार्ट में डिवाइड करती है? 2 पार्ट में, एक अलोंग ओरिजिन और एक फारदेस्ट फ्रॉम ओरिजिन. सो हम इनइक्वालिटी के हिसाब से देखेंगे कि हमारा शेडर रीजन कौन सा वो लाइन दे रही है, उसके हिसाब से जो सारी इक्वेशन एक कॉमन शेडर रीजन देंगी, वो उस रीजन को बोलते हैं फिजिबल रीजन. ओके. सो जो हमारे पास फिजिबल रीजन आ गया, उसके फिर हम सारे कोऑर्डिनेट्स निकालेंगे. जो भी हमारे पास, मान लीजिए हमारे पास ये फिजिबल रीजन आया, मैं आर्बिट्री बना रहा हूं, मान लो एक लाइन ये है, एक लाइन ये है, ठीक है, ये फिजिबल रीजन है. ओके. सो फॉर दिस फिजिबल रीजन, व्हाट आर द एक्सट्रीम कॉर्नर पॉइंट्स? O, A, B, and C. So first step is we have to find the coordinates of A, B, and C. O is understood, origin 0, 0. So how we can solve the point ABC? Using elimination method, substitution method to solve the equation, two linear equations. Okay. And fifth steps is for each these points O, A, B and C, like we have 0, 0, 0, 3, 2, 4 and 3, 0. Suppose we have these 4 corner points. So for these 4 points, we put the values of x and y in objective functions. Okay, we will put these values in objective function to calculate the values of objective function at these 4 points. Okay, now we will see if we have to maximize the objective function, so the point which gives the maximum value, like this gives 5, this gives 4, 6 and 8. Just assume. So if my question is to maximize the objective function, so what will be my answer?
C.
Which point? C. So means 3, 0 is my optimal point. Okay. So 3 is for first design variable, 0 for second design variable. So if we have to minimize the objective function, what will be our answer? Origin. Okay. This is just example, but in practical we will see there will be some value. Now we solve that bowls and mugs mathematical model using graphical. So now you please proceed to solve this problem. Okay, first of all, we will do this step by step so that you can understand. So what is our equation? Have you noted down these equations? Objective function is 40x1 plus 50x2. Constraints are, you please note down. Okay, first step is, like we have seen just now, like we have x1 is our bowls, x2 is mugs. So we consider these two variables as our axis, x coordinates. Okay, like we can say this is x-axis, this is y-axis. This is x1 and this is x2. Clear first of all? Okay. Second is, we will draw first equation. What is our first constraint? X1 plus 2x2 is equal to 40. So everybody knows how to draw a line. What we will do, as we do in our small classes, x1, x2. When we put x2 0, what is x? 40. And when x1 is 0, what is x2? 20. Okay, so what is the equation? Clear? So this is our equation, x1 plus 2x2 is equal to 40. But important is, we have to draw an equality. What is our inequality? x1 plus 2x2 less than equal to 40. So how we can choose? देखो, ये लाइन इस प्लेन को दो पार्ट्स में डिवाइड कर रही है, एक ऊपर वाला और एक नीचे वाला. हम कौन सा लेंगे? हम ऊपर वाला लेंगे, नीचे वाला? क्यों? लेकिन इसका प्रॉपर वे क्या होता है? सबसे इजी तरीका हमेशा याद रखो, आप x1 x2 को 0 पुट करो. हमेशा कंस्टेंट इनइक्वालिटी के अंदर आप ओरिजिन वैल्यू पुट करो. जब आप x1 x2 0 पुट करोगे, 0 plus 2 is 0 less than equal to 40. Is it true or false? True. It means ये लाइन हमें वो वाला रीजन देगी जिसके अंदर कौन आएगा? ओरिजिन आएगा, क्योंकि ओरिजिन कोऑर्डिनेट जो है वो इस इक्वेशन को क्या कर रहे हैं? सेटिस्फाई. तो इसका मतलब मेरे पास ये वाला रीजन आएगा इसका. क्लियर हुआ? तो ऊपर वाला पार्ट हमने क्या कर दिया, छोड़ दिया। हमेशा आप इस इक्वेशन के अंदर ओरिजिन पॉइंट डालो, अगर वो सेटिस्फाई कर रहा है तो ओरिजिन वाला पार्ट आएगा, नहीं कर रहा तो दूसरे वाला पार्ट आएगा। ओके, सो नाउ प्लॉट द सेकंड इक्वेशन। This is the physical reason we have drawn. Now this is second equation. 4x1 3x2 is 120. So what will be the coordinates? If we put x2 0, x1 is 30. If x1 is 0, what will be x2? 40. Sorry. Okay, so similarly, when we put 0, will inequality will be true or false? If we put 4x1 plus 3x2 less than equal to 120, if we put an origin here, so will inequality be true or false? True. It means this line will also come in this side, origin part. Is it fine? So now we have to see the common region of both lines. Okay, so which will be the common line, common area? This one. Okay, now I will erase the rest of the region. So this is our common region. Okay. So now you can see we have these three types of points, R, S, and T. These are three areas. R region, this is the R region is feasible region. Okay. So what are the coordinates of these 3 points? This is first point. This is second point. We can see this is R, and this is C. What are the coordinates of extreme points? What are the coordinates of extreme corner point? Yes, please tell. First is origin 0, 0. This, what is the point of this coordinate? B 0, 20, and C is 30, 0, and one point is R. So you should calculate the coordinate of point R. What will be the coordinate of point R? You should calculate. Yes, has anyone found coordinates of this point R? We can multiply first equation by 4. 10, 8. X2 is 8. X2 is 8. So put X2 is 8 here. 16. So point is X1 is 24. Okay. X1 is 24. So what are the coordinates of point R? 24, 8. Is it clear? Okay, so now here till this part, for both isoprofit method and extreme point evaluation method, these steps we have to follow. Okay, so now after this there are two ways. Okay, first we are considering isoprofit method. Is it clear to everyone? Okay, now important part. Now see, we are again drawing this graph. First is 20,0. Okay, clear? So first we see isoprofit method. So in isoprofit method हम क्या करते हैं, सबसे पहले ऑब्जेक्टिव फंक्शन को कंसीडर करेंगे. ठीक है, इसमें हमारा फिजिबल रीजन क्या है? हमारे पास ऑब्जेक्टिव फंक्शन क्या था? z इज इक्वल टू 40x1 प्लस 50x2. ओके, सो हम क्या करते हैं, हम अज्यूम करते हैं कि हमारी ऑब्जेक्टिव फंक्शन की वैल्यू इतनी आएगी. आइसोप्रोफिट मेथड में हम क्या करते हैं कि हम ये अज्यूम करते हैं कि हमारी ऑब्जेक्टिव फंक्शन की वैल्यू इतनी आएगी. अब क्वेश्चन ये राइज होता है कि ऑब्जेक्टिव फंक्शन की वैल्यू इतनी आएगी, वो कितनी अज्यूम करें. उसके लिए हम क्या करते हैं, इनका एलसीएम ले लेते होते हैं. हम इन दोनों पैरामीटर का क्या लेंगे, एलसीएम. यू जस्ट टेक एलसीएम 40, 50. We can just let go by 10. So LCM is 200. Okay, so we will start with 200. We will start with 200. Very easy method. Okay, so first we put 40x1 plus 50x2 is equal to 200. Please draw this line. Now please draw this line, this one. But what will be the coordinates? 5, 4. If we put x2 0, what will be x1? 5. And if we put x2 0, x1 is, sorry, now we put x1 0, x2 is 4. So draw this line. So this is line 40x1, 50x2 is 200. Is it clear? But what is our objective? We have to select that line. We will draw the parallel lines of this extreme point. हमारा एम ये होता है कि हमें एक ऐसी लाइन लेनी है जो फिजिबल रीजन, जो हमारा फिजिबल रीजन है उसमें ओरिजिन से सबसे फारदेस्ट लाइन हो. ठीक है, हमारा एम क्या है कि हमने ऐसी ऐसी पैरेलल लाइन बनाते जाना है और तब तक बनाते जाना है जब तक ऐसी लाइन हमें ना मिल जाए जो ओरिजिन से सबसे फारदेस्ट डिस्टेंस पे हो. और आप ये बताओ कि इस फिजिबल रीजन में सबसे फारदेस्ट डिस्टेंस वाली लाइन कौन सी होगी, जो कहां से पास करेगी, आर में से. तो हमें ये ऐसे पैरेलल लाइन बनाते जाना है. एम क्लियर हुआ? हमें ऑब्जेक्टिव फंक्शन की वैल्यू ऐसे पुट करते जाना है, तब तक करते जाना है जब तक हमें एक ऐसी लाइन नहीं मिल जाती जो ओरिजिन से सबसे फारदेस्ट डिस्टेंस पे. ठीक है, हम इसके बाद फिर ट्राई करते हैं. अब इसके मल्टीपल शुरू कर दो. 40x1 plus 50x2 is equal to 400. Okay, now please draw this line. What will be the coordinates? 10, 0 and 0, 8. Now the second line. Will it be solve our purpose? Will it be solve our purpose? No. So we have to proceed further. Now third multiple is 600. What will be coordinates? Yes, please. 150, comma. What will be coordinates? 150 and yes, please please say 150 and 120. Okay, 15. Yes, 15 and 12. So this is third line. Okay, this is third line. Now it will also it will not solve our purpose. So next is 800. So still now I'm showing you here only. We will put these four values. Okay, 40x1 plus 50x2 is equal to 800. 40x1, 50x2 is equal to 1200. And next is 40x1, 50x2 is 1600. We will, you please draw these three lines. Okay, first with 800. With 800, we have just these points, 15, this light blue. Okay, and with 1200, we will again have towards origin. We will not find any farthest line from the origin. But if we put 40x1 plus 50x2 is equal to 1600, then that line will go beyond the feasible region. It means that line will not solve our purpose. So we have a value which lies between 1200 and 1600. Okay, अगर हम 1200 से वैल्यू ड्रॉ करते हैं, एक 1600 से ड्रॉ करते हैं, तो 1200 वाली लाइन R से पहले रहती है और ये वाली लाइन 1600 वाली लाइन R से बाहर जाती है. इट मीन दोनों ही हमारा पर्पस सॉल्व नहीं कर रही. तो इसका मतलब आंसर हमारा 1200 भी नहीं होगा, 1600 भी नहीं होगा, इसके बीच में लाई करेगा. ठीक है, तो जो ये वाला मेथड है ये हमारा बहुत टाइम कंज्यूमिंग होता है, इसलिए हम इसको कभी भी मतलब बहुत ही रेयर यूज करते हैं. मुझे नहीं पता इसका कहाँ यूज होता है, लेकिन हम जनरली एक्सट्रीम इवेल्युएशन मेथड यूज करते हैं. ठीक है, तो इसलिए हमें इसको ऐसे प्रैक्टिस सेशन में आर्बिट्री वैल्यूज पुट करते रहना है, लेकिन वैल्यू पुट कैसे करनी है वो मैंने आपको बताई. ठीक है, कि पहले एलसीएम ले लो, फिर उसके मल्टीपल्स लेते चलो, फिर उसके बाद यहाँ आके हमें पता चल गया 1600 में आके पता चल गया कि हमें इससे आगे नहीं जाना. अब हमने वैल्यू 1600 से कम ही रखनी है. ओके,
ये बिल्कुल पॉइंट पे टच होके जाएगी लाइन,
वही वाली कंसीडर करनी है.
तो इसके बाद भी और भी ज्यादा फाइनाइट,
बिल्कुल फाइनाइट, बहुत फाइनाइट चाहिए होता है. हमें वो वाली लाइन चाहिए जो बिल्कुल आर पॉइंट्स, क्योंकि वही सबसे फारदेस्ट डिस्टेंस पे होगी. जो लाइन ओरिजिन से सबसे फारदेस्ट डिस्टेंस पे है वो वही लाइन होगी जो आर से पास करेगी. ठीक है, हम ये करना एक बार. जो नोडल सेंटर्स हैं उन अभी फिगर्स देखेंगे, उनको पता चलेगा. See, now we put 40x1 plus 50x2 is equal to 800. 40x1 plus 50x2 is 1200. 40x1 plus 50x2 is 1600. So जब हम 1200 वैल्यू पुट कर रहे हैं तो वो R से पहले रह रही है, और जब हम 1600 पुट कर रहे हैं तो वो फिजिबल रीजन से बाहर जा रहा है. इट मीन्स कि वो रीजन से बाहर चला गया. इट मीन्स हमने 1600 से पहले रहना है. तो ये बहुत हिट एंड ट्रायल मेथड से वैल्यू पुट करते 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 हमें एक ऐसी लाइन मिलेगी जो आर पॉइंट से पास करेगी. ओके, सो हम इस मेथड को बहुत कम यूज करते हैं. तो फिर सोल्यूशन कैसे निकालेंगे? हम उसके लिए मेथड यूज करते हैं एक्सट्रीम इवैल्यूएशन मेथड. सबसे इजी मेथड क्या है? हम ये सभी के कोऑर्डिनेट्स निकालेंगे. O A, R and C. ओके, इन चारों पॉइंट्स पर हमने ऑब्जेक्टिव फंक्शन की वैल्यू देखी कि क्या वैल्यू आ रही है. सबसे पहले हमने वैल्यू पुट की ओरिजिन में 0,0, क्या वैल्यू आएगी 0. फिर हमने ए पुट किया 0, उसके हिसाब से ले लेते हैं सी पॉइंट. C point is 30,0. What will be the answer? 40 into 30 plus 50 into 0. Answer is 1200. Good. Next point is B. B is 24,8. What will be the value? Yes, please calculate. 1360. 1360. And next is A. A is 0,20. Answer? 1000 is 1000. So our aim is to maximize the objective function. So what will be the our answer? 1360. 1360. And how much bowls and mugs should be produced so that company will get maximum profit? Please tell, how much bowls? 24 bowls and 8 mugs. If company will produce, then company will get a definitely maximum profit in the given constraints. For the given constraints or labor constraints and material constraints. Okay, so these are the two methods by which we can solve the graphical solution. Okay, has anybody has any doubt? Yes, nodal center.
सर जब हम पैरामीटर्स की बात कर रहे हैं
जी,
तो जो हमारी z की इक्वेशन है उसमें जो हमारे कांस्टेंट्स हैं उसमें जो हमारे
40 and 50
they are parameters और जो constraints में हमारे
design variable.
1 and 2 will be our parameters or 40 and 50 will be our parameters.
1 or 2, you are talking, you are telling in constraints. Yes, 1 and coefficients are basically parameters.
Coefficients are in constraint one equation or z1?
Say in both. In both, we can say 40 and 50 objective functions are parameter. In constraints, 1 and 2 are parameters. Okay, and x1, x2 are design variables. Okay.
Then why don't we take the design variable less than 1?
Sorry?
When we constrain x1 and x2 greater than or equal to 0.
Yes.
Why don't we consider it as negative?
Why? Because balls and mugs can't be negative. In practical problems, हम ये कैसे कह सकते हैं कि मग की वैल्यू -1 होएगी या बॉल्स की वैल्यू -1 होएगी? ये तो प्रैक्टिकल चीजें जा तो होएगी या नहीं होएगी. अगर होएगी तो 1 होएगी. ठीक है ना? तो जो बॉल्स एंड मग्स है उसकी मिनिमम वैल्यू 0 होएगी. ठीक है? तो प्रैक्टिकल जब ट्रांसपोर्टेशन प्रॉब्लम है, भले न्यूट्रिशियस फूड है, विटामिन ए, विटामिन बी, जा तो होएगा या नहीं होएगा. इनकी वैल्यू कभी नेगेटिव नहीं हो सकती. Because these are living things, or we can say these are the things which we can produce to manufacture. Yeah. In linear programming problems we are talking about here. Okay, because I told you earlier that linear programming problem are used in engineering and non-engineering problems.
यहाँ पर हम लोगों ने केवल 4 जो पॉइंट्स हैं हमारे
जी,
कॉर्नर पॉइंट, उन पे अपनी वैल्यू देखकर उसमें से जो मैक्सिमम हमारा उसको मान लिया कि
that will be maximum.
बीच में एरिया में कहीं पे हमारी मैक्सिमम वैल्यू
नहीं हो सकती. आप वैसे दिस इज गुड क्वेश्चन, प्लीज नॉट टॉकिंग. जो हमारे पास ये फिजिबल रीजन है, इसके बीच में इनफाइनाइट पॉइंट लाई करते हैं. आप कोई भी आर्बिट्री पॉइंट इसमें पुट करके देख लो, उसकी वैल्यू 1360 से कम आएगी। और सिमिलरली जैसे आपका क्वेश्चन था कि अगर हम अब हमें पता चल गया कि मैक्सिमम वैल्यू कितनी आ रही है 1360। अगर आप आइसोप्रोफिट लाइन मेथड में 40x1 प्लस 50x2 इज इक्वल टू 1360 पुट करोगे तो वो आपकी लाइन आर से पास करेगी और वो फारदेस्ट डिस्टेंस पे होगी, ठीक है ना। लेकिन वो बहुत हिट एंड ट्रायल मेथड है, इसलिए हम उसको बहुत रेयर यूज करते हैं, हम जनरली इसी को यूज करते हैं।
इसमें हमने जो बाउंड वेरिएबल्स रखे हैं,
हाँ जी,
जो बाउंड वेरिएबल तो क्या वो भी कांस्टेंट ही कहलाए जाएंगे?
कांस्टेंट मींस
जैसे कांस्टेंट्स हम ये ले रहे हैं x1 प्लस 2x2
कंस्ट्रेंट्स,
कांस्टेंट, तो ये भी वही बोली जाएंगे कि जो बाउंड वेरिएबल्स को हम बोल रहे हैं।
यस यस, बेसिकली यहाँ पे कोई लोअर बाउंड हमारी 0 है और अपर बाउंड इन्फिनिटी है। लेकिन कई बार क्या होता है, जैसे मान लो हम मैकेनिकल के अंदर आपने वाइब्रेशन पढ़ा होगा, उसमें हम हुक्स मेथड लगाते हैं, होवल्स मेथड लगाते हैं, तो उसमें हमारे पास बाउंड्स होते हैं कि भाई ये 0 और 2 से ज्यादा नहीं हो सकती, है ना। जब हमारे पास कैंटिलीवर की एग्जांपल्स होती हैं, बीम की एग्जांपल होती हैं, तो उसमें लगाते हैं कि हमारी वैल्यू 0 और 2 के बीच में नहीं होगी, तब इनकी वैल्यू और प्रेफर होती है, ठीक है। तो ये लोअर बाउंड हो जाता है और ये अपर बाउंड हो जाता है, ठीक है। सो एनीबडी हैज क्वेश्चन फ्रॉम नोडल सेंटर? Okay, so this is the final answer. Now there are some exceptional cases in graphical method. First is alternative solution. Okay, now you please solve this problem because this method just need practice. Maximize z is equal to 2x1 plus 4x2 subjects to these constraints. We will solve this equation, but here we use only graphical method by extreme valuation point. We will not try isoprofit for this equation. Yes, you please solve all this equation. Z is equal to 2x1 plus 4x2 subjects to constraints x1 plus 2x2 less than equal to 5, x1 plus x2 less than equal to 4, and x1, x2 are non-negative. x1 plus 2x2 is equal to 5. So, what are the coordinates? Yes, please. 5, 0 and 0, 2.5. And second is x1 plus x2 is equal to 4. x1 plus x2 is equal to 4. So point is 4, 0 and 0, 4. Okay, now we have to see what are our inequalities for these lines. For this line AB, what will be our feasible, what will be our scheduled reason for line first? What is the procedure to check? We put value 0 and 0. Very good. x1 plus 2x2 is equal to 5. 0 plus 0 is equal to 5 less than equal to 5. Is it true or false? True. So it means this line has a region containing this part. We can just light arrow. Similarly, second, this line. So what is feasible region? This. Okay. So please calculate the coordinates of point C. 3, 1. 1. Please calculate. X1 plus 2x2 is 5. X1 plus x2 is 4. Yes, this coordinate is 3, 5. Okay. Now, what is the next step? Put all these 4 coordinates in objective function. O, A, so by putting the origin point, what will be the value? 0. And by putting 0, 2.5?
10.
Yeah, 10. And by C?
All are 10.
All are 10.
All are 10. I mean, last one is 8.
3. This is 8.
This one is last one is 8.
This is 10. Okay. So in this equation, we have 2 solutions. Okay. So there are some problems which contains an alternative solution. If we produce 0 and 2.5, like if we consider balls and mugs here, so 0 balls and 2.5 mugs, then we can optimize our profit. If we produce 3 balls and 1 mugs, we can do our maximized profit. Okay. I just saying, because this is not example of balls and mugs, but generally we can say 0 of x1, 2.5 of x2 will give maximized profit, 3 of x1 and 1 of x2 will give maximized profit. Okay. So here we have 2 answers. See, we can see now. We can see in graph presentation. Extreme point 0, A, B, C. So here we have constraints like this. Okay, this line, BC line, contains the points C and B, which gives the maximum optimal solution. Is it clear to all, everyone? Any doubt? No. Yes, from Nodal Center. Okay. Next is infeasible solution. Next is infeasible solution. There are some, as we discussed earlier, what are infeasible solution? Yes, anyone?
You cannot satisfy.
Yeah, if any constraints, if the values of decision variables violates at any one of the constraints, then that equation, that model will give us infeasible solution. Okay, the values of decision variables must satisfy all the constraints to get a feasible solution. Okay, so we should solve this equation now. Yes, please note down the equation, nodal centers. Z is equal to x1 plus x2. S is selects 2 constraints, x1 plus x2 less than equal to 1, minus 3x1 plus x2 greater than equal to 3, x1, x2 are non-negative. So here, first of all, we produce x1 and x2. First equation is x1 plus x2 is 1. X1 plus x2 is 1. What will be coordinates? Yes, please. 1, 0 and 0, 1. 1, 0 and 0, 1. Second is minus 3x1 plus x2 is 3. See, for this line, which will be our shaded region? Towards origin. 0, 0 less than equal to 1 satisfied. So this one. For second line, what will be coordinates? Minus 1, minus 1, 3. Okay. X1 is minus 1 and x2 is 3. So this is our piece. Okay. See, now we have to check. Minus 3x1 plus x2 is 3. If we put origin, will it satisfy? 0, 0 greater than equal to 3. True or false? False. It means this line does not contain the region which contain origin. Okay. So we have to move this side. Okay. So this line says this side. And this line says this side. So is there any common region? Is there any common region? No. It means we have to, there is no solution, no feasible solution. We can see here. You can see in presentation. Okay. X1 plus x2 is 0, like this side only, and minus 3x1 plus x2, because we have to stay in first quadrant also, na? What are our next conditions? X1 greater than equal to 0, x2 greater than equal to 0. So we have to stay only in first quadrant. So in this part, we cannot consider anything. So that's why there is no feasible reason. Okay. So is there any common reason? No. It means this model has no feasible solution. We can say infeasible solution. So these types of problems, there also exist sometimes. So when we do research, when we do mathematical modeling in our research, so there will be some constraints. So we have to change our constraints. है ना, हमने सारा काम कर लिया और बाद में जब उसकी एनालिसिस करने लगे सॉफ्टवेयर में या मॉडलिंग में, तो पता चला कि ये कंस्ट्रेंट्स तो उस ऑब्जेक्टिव फंक्शन को वायलेट कर रहे हैं, ये कंस्ट्रेंट्स की वैल्यू को सेटिस्फाई नहीं कर रहे, तो हमें शुरू से सारे डिजाइन वेरिएबल सेलेक्ट करने पड़ते हैं. तो इसलिए सबसे पहला स्टेप हमारा ये होता है कि प्रॉब्लम को समझें और उसके डिसीजन वेरिएबल कंस्ट्रेंट्स क्या होंगे उसको चूज करें, है ना. जब हम वैसे भी कोई थीसिस करते हैं या रिसर्च करते हैं तो पहला काम यही होता है कि हम टॉपिक को डिसाइड करें, है ना. काम तो हो ही जाएगा. अगर हमारे पास मैथमेटिकल मॉडल सही तरह से बन गया तो सॉल्व हम उसको इजीली कर सकते हैं. अगर हमने मॉडल गलत बना लिया और सारा प्रोसीजर हमने सॉल्व कर लिया, उसके बाद पता चला कि वो तो हमारी सोल्यूशन वायबल ही नहीं है, वो सोल्यूशन वो मॉडल मेरा सही नहीं है, तो फिर हमारा बहुत समय वेस्ट हो जाता है. ठीक है. So we can see here shaded region is 5. Next is unbounded solution. Third is unbounded solution. This is the third exceptional case in graphical solution. Yes, please note down these equations. we have to maximize the objective function 40x1 plus 60x2 with constraints 2x1 plus x2 greater than equal to 70, x1 plus x2 greater than equal to 40, x1 plus 3x2 greater than equal to 90, and x1, x2 are non-negative. So now you should proceed for these equations. First is using first equation, what will the coordinates? What is the abscissa and ordinate? 35, 35. (35, 0, 0, 35). Next is x1 plus x2 is 40. What will be the coordinates? 40, 0 and 0, 40. Next is x1 plus 3x2 greater than equal to 90. What will the coordinate? Hanji? 90, 30. 0, 30 and 90, 0. So now important is we have to choose the reason which these constraints follows. Okay? Yeah, this is sure that we have to remain in this first quadrant only. First is 2x1 plus 2x is 70. Put the region here. Will it true or false? False. It means we have to 35 line. This type. Is it okay? Okay. This line does not contain origin. Second is x1 plus x2 40. 0 plus 0 is 40. True or false? False. So again we have to choose above one portion. Third is x1 plus 3x2 90. False. So we have to again move upwards. So what is the common region now? Next.
There is common region, but that is not above the.
Yes, please see this presentation now. You can see in all these three lines, we do not contain the region having origin. So these three lines give the shaded region above this point. You can see this one. Okay, so if in this question we have to minimize the objective function, then we can find the values. क्योंकि हमें यहाँ पर ये पूछा गया था कि इस फंक्शन की मैक्सिमम वैल्यू क्या होगी, तो मैक्सिमम वैल्यू कितनी होगी? इनफाइनाइट, बिकॉज देयर इज नो बाउंडेशन ऑफ x1 एंड x2. ओके, अगर इसी क्वेश्चन में हमें मिनिमाइजेशन पूछ लेते तो फिर हम क्या करते? इसके कोऑर्डिनेट निकालते, इसके निकालते और इसके निकालते. तीनों में से जो वैल्यू हमें कम देता वो हमारा आंसर हो जाता. लेकिन क्योंकि ये मैक्सिमाइजेशन की प्रॉब्लम है तो इसके अंदर हमारे पास कोई भी सोल्यूशन नहीं है. तो इस ऐसी प्रॉब्लम्स को क्या बोलते हैं? अनबाउंडेड. कि ये रीजन बाउंड नहीं है तो इसका आंसर इनफाइनाइट हो सकता है कि x1 x2 की वैल्यू कुछ भी हो सकती है. क्लियर है सबको? अगर इसी में मिनिमाइजेशन पूछ लेते तो फिर क्या आंसर आता? फिर हम 0,40 एंड दिस पॉइंट एंड दिस पॉइंट, इन तीनों को ऑब्जेक्टिव फंक्शन में डालते और चेक करते कि हमारे पास ऑब्जेक्टिव फंक्शन की वैल्यू कहां पे सबसे कम आ रही है. वो तो इजी है, वो तो हमने अभी किया ही है. तो ये हमारे पास तीन एक्सेप्शनल केसेस हैं जो लीनियर प्रोग्रामिंग के ग्राफिकल मेथड्स में देखे जाते हैं. ठीक है, और इन्हीं से हमें बचना होता है. जब हमने कोई प्रैक्टिकल मॉडल बनाना है तो तो हमने इन तीनों चीजों से बचना होता है। अगर हमारे किसी सिचुएशन में हमने सब कुछ बना लिया, डाटा ले लिया, सारी हमारे पास एनालिसिस हो गई, बाद में पता चला हमारा मॉडल ही सही नहीं है, तो फिर हमारा सारा टाइम, रिसर्च टाइम क्या हो जाता है, वेस्ट हो जाता है। ठीक है, किसी को कोई डाउट हो इन 3 केसेस में? अभी हम एक इसके नेक्स्ट स्टेप पे चलेंगे कि हमारे पास जनरल जो प्रॉब्लम होती है वो सीधा मैथमेटिकल मॉडल में नहीं होती है। मैथमेटिकल मॉडल तो हमें जनरेट करना पड़ता है। मान लो आपको कोई भी इंडस्ट्री प्रॉब्लम मिलती है या कोई भी आपको हेल्थ डिपार्टमेंट से प्रॉब्लम मिलती है, तो वो आपके पास एक स्टेटमेंट में होती है। वो आपको कहेंगे कि भाई हमारे ये ऐसे ऐसे करके कंस्ट्रेंट्स हैं, तो उसको मैथमेटिकल मॉडल में कैसे बनाना है वो भी हम देखेंगे। ठीक है, तो आपके सामने ये प्रॉब्लम है, आप इसको मैथमेटिकल मॉडल में बनाएं। पढ़ो, ये स्लाइड देख लीजिए। Yes, nodal centers, you please do. A dietitian wishes to mix 2 types of foods in such a way that vitamin contents of the mixture contain at least 16 units of vitamin A and 20 units of vitamin C. Food A contains 4 units per kg of vitamin A and 2 units per kg of vitamin C. Food B contains 2 units per kg of vitamin A and 2 units per kg of vitamin C. It costs rupees 40 per kg to purchase food A and rupees 60 per kg to purchase food B. So formulate this problem as a linear programming problem to minimize the cost of such a mixture. Okay, so you please formulate the mathematical model of this equation, this problem. Yes, you have some time. First, understand this problem. As we did one question on bowls and mugs, so make that table so that we cannot repeat some mistake here. Nodal centers, I will ask from you. You should prepare the mathematical model for this statement. First of all, you have to prepare food A and food B. Okay, so जैसे प्रैक्टिकली क्या होता है, मान लीजिए हमारे पास कोई, हम किसी डाइटिशियन के पास जाते हैं, तो वो हमें ये कहता है कि आपको इतने न्यूट्रिएंट्स लेने हैं। ठीक है, तो वो न्यूट्रिएंट्स हम अब जब हम डाइट लेते हैं तो कोई एक चीज तो नहीं लेते। तो मान लो हमने उसने कहा कि आप एक समय पे 2 चीजें खाएं, डाइट फूड 1 खाएं एंड फूड 2 खाएं। तो फूड 1 के अंदर उसने 2 चीजें बता दी, विटामिन ए इतना है और विटामिन सी इतना है। और उसी समय जो दूसरी आइटम है उसके अंदर विटामिन ए इतना है और विटामिन सी इतना है। और ये भी बता दिया कि विटामिन ए आपको एक समय पर इतना लेना है या उससे ज्यादा लेना है, इससे कम तो लेना नहीं है। इसमें एटलीस्ट बोला हुआ, एटलीस्ट माना कम से कम 16 यूनिट्स विटामिन ए की आपको लेनी ही है। ठीक है, तो और ये बता दिया कि फूड ए जो होगा उसकी 40 पर केजी कॉस्ट है और फूड बी की 60 पर केजी। ये तो हमारा क्या बन जाएगा, ये हमारा क्या हो गया, ऑब्जेक्टिव, क्योंकि उसने मिनिमाइज दी कॉस्ट बोले तो बहुत इजी हो गया। तो हमें क्या करना है, मिनिमाइज z इज इक्वल टू 40x1 एंड 60x2। सो हाउ वी शुड प्रोसीड फॉर दिस टेबल, यू प्लीज सी। Because once mathematical model is prepared, then we can solve the model by using graphical method. See, you first made food A and food B. Okay. मैम उनको दिख रहा है उधर से. This is vitamin A, vitamin C, and this is profit. Okay. So food A, how many profit? Yes, please tell. Rupees 40. Okay, because 40 per kg to purchase food A, and this is rupees for 60. We can say cost. Okay. Now जो फूड ए जो बन रहा है उसके इंग्रेडिएंट्स कितने कितने हैं? 4 यूनिट्स पर केजी ऑफ विटामिन है. मान लीजिए हमने विटामिन को मान लिया x और इसको मान लिया y. जब हम जो पहले से ले रहे हैं x1 x2. ओके. सो फूड ए में कितना आ गया? विटामिन ए कितने बताइए प्लीज? 4. और विटामिन सी कितना है? 2. फूड बी में 2 and 4. और हमें ये बता दिया उसने कि जो विटामिन ए है वो हमने कितना लेना है मिनिमम? एटलीस्ट 16 यूनिट्स. मतलब ये जो विटामिन ए है ये 16 से क्या होना चाहिए? ज्यादा. 16 से क्या होना चाहिए? ज्यादा. और विटामिन सी कितना होना चाहिए? 2 से ज्यादा 20. ठीक है. तो अब हम इक्वेशंस आराम से बना सकते हैं. अगर आपको ये टेबल बनाना आ गया कहां पे क्या रखना है तो हम बहुत इजीली मैथमेटिकल मॉडल बना सकते हैं और हम बहुत अच्छी सॉल्यूशन निकाल सकते हैं. तो अब तो इक्वेशन बना लेंगे. क्या क्या इक्वेशन बनेगी? फर्स्ट ऑफ ऑल मिनिमाइजेशन और मैक्सिमाइजेशन. मिनिमाइजेशन. Minimize z is equal to 40x1 plus 60x2. Okay, this is the items of food A and items of food B. ठीक है. जो हमने x1 यूनिट्स ली है वो फूड A के लिए ली है और x2 यूनिट्स जो ली है वो फूड B के लिए. So first equation is, what is the equation for first? 4x1 plus 2x2. We have to move this side. 4x1 2x2 greater than equal to 60. Because we are right. Please tell the type of equation. But we can name this constraint. Which inequality constraint? This is vitamin A constraint. Okay, because this is vitamin A. Vitamin A constraint and this is vitamin C constraint. What is vitamin C constraint? 2x1 4x2 is greater than equal to 2x1 plus 4x2 greater than equal to 20. And most important, x ये जब हम पेपर चेक करते हैं तो ये गलतियां होती हैं हमेशा. हम सारे कंस्ट्रेंट्स लिख देते हैं और नीचे x1 और x2 greater than equal to 0 नहीं लिखते क्योंकि वो अंडरस्टूड होता है. बट अंडरस्टूड तो होता है लेकिन वो सारा गलत हो जाता है. ठीक है. x1 x2 greater than equal to 0. सभी को समझ आया कैसे बनाते हैं स्टेटमेंट से मैथमेटिकल? सो दिस इज द आंसर. फोर x1 plus 2x2 greater than equal to 16. 2x1 plus 4x2 greater than equal to 20. x1 x2 greater than equal to 0. एक और प्रैक्टिस के लिए एक और बनाइए ताकि आपको और क्लियर हो जाए। अब आपको खुद बनाना है। A company manufactures two types of screws, P and Q. Each type of screw requires the use of two machines, an automatic and a hand operated. It takes 4 minutes on the automatic and 6 minutes on hand operated machines to manufacture a package of screws P, while it takes 6 minutes on automatic and 3 minutes on hand operated machines to manufacture a package of screw Q. Each machine is available for at the most 4 hours on a day. The manufacturer can sell a package of screws P at a profit of rupees 10 and screws Q at a profit of rupees 12. Formulate the problem in order to maximize profit. पहले इस प्रॉब्लम को समझिए, प्रैक्टिकल एक विजन बनाइए और फिर इस प्रॉब्लम को सॉल्व कीजिए। सबसे पहले हमें क्या देखना होता है कि हम लोग किस चीज की मैन्युफैक्चरिंग कर रहे हैं। जैसे पिछले क्वेश्चन में हमारा कौन सी चीज मेन थी? फूड, क्योंकि फूड किसी चीज से मिलके बनेगा। विटामिन ए किसी चीज से मिलके बनेगा या फूड मिलके बनेगा? फूड। तो फूड ए के जो इंग्रेडिएंट्स हैं वो इक्वेशन डिसाइड करते हैं। इसमें क्या है? स्क्रू बन रहा है। स्क्रू बनने के लिए 2 मशीनें चाहिए, एक ऑटोमेटिक चाहिए और एक हैंड ऑपरेटेड चाहिए। तो वो हमारे डिजाइन वेरिएबल हो गए। ठीक है, ऑटोमेटिक और हैंड ऑपरेटेड हमारा क्या हो गया? डिसीजन वेरिएबल्स कि जिसको लेकर के हमारे जो ऑब्जेक्टिव फंक्शन है वो कंस्ट्रेंट होएगा। तो बनाइए इक्वेशंस, ये इंपॉर्टेंट है इसमें। उधर से आवाज आएगी ना? कुछ मतलब पूछ तो नहीं रहे कुछ? ओके। Yes, Suresh Gyan Vihar University, Jaipur.
Yes, sir.
Yes, do you have any doubt?
No, the performance function will be z is equal to 10x plus 12y और constraint equations जो होंगी वो हैं 4x plus 6y less than equal to 240 और 6x plus 3y less than equal to 240.
Okay.
So
most important
x y greater than equal to 0.
Okay. Panipat Institute. Yes, please have a seat, sir. Panipat Institute. चलो हम अब इसको देखते हैं कैसे करना है। आपने बना लिया सबने? क्या क्या बनेंगी इक्वेशंस? सबसे पहले टेबल बनाते हैं P and Q. First is automatic hand operated, and next is profit. Profit is, first of all, we have to assume that there are x1 units of P and x2 units of Q. X1 units and x2 units. So what will be our objective function? Profit for P is 10 and this is for 12. Clear? So see, problem is saying that each type of screw requires the use of two machines, automatic and hand operated. It takes 4 minutes on the automatic. जो P स्क्रू P को बनने के लिए 4 मिनट ऑटोमेटिक मशीन चाहिए और 6 मिनट्स हैंड ऑपरेटेड चाहिए, और इसको 6 चाहिए और इसको 3 चाहिए। और कंस्ट्रेंट्स क्या लगाए कि एक जो मशीन है वो मैक्सिमम एक दिन में कितना काम कर सकती है या कितनी अवेलेबल है, 4 आवर्स। तो क्योंकि हमारे ये ऑटोमेटिक जो प्रोसेसिंग हो रही है वो मिनट्स में है, तो हम उसको भी किस में लिख लेंगे, मिनट्स में। एट मोस्ट मींस मैक्सिमम। सो विच इनइक्वालिटी, लेस देन इक्वल टू 240 and less than equal to 240. So constraints are 4x1, 6x2 less than equal to 240, 6x1, 3x2 less than equal to 240, and x1, x2 is greater than equal to 0. So now we can see on presentation 4x1 plus 6x2 less than equal to 240, 6x1 plus 3x2 less than equal to 24, and x1, x2 greater than equal to 0. Yes, in slide they should be 240. And objective function is x1 plus 12x2. Clear? So now we will solve the equations now. We will solve this equation using both methods, graphical extreme corner point valuation method and isoprofit cost method. Yes, please do. So that you will be familiar with this graphical solution method. Maximize Z is equal to $50x plus 15y, 5x plus y less than 100, x plus y less than 60, and xy is greater than equal to 0. Yes, please solve and find the optimal solution for this mathematical model problem. First of all, draw all these lines, constraint equations on a graph. Yes, Sobha Saria Engineering College, Rajasthan. Sobha Saria Engineering College, Rajasthan.
Hello?
Yes, yes.
Yes, sir. We are trying, sir.
Yes, yes, sure. I will ask from your center.
Okay, sir.
Sir, this is Suresh Gyanvihar University.
Sorry?
Suresh Gyanvihar University.
Yes, 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 please, sir.
Our solution is Z is equal to 540 on X is equal to 30 and Y is equal to 20.
Okay, you are telling the answer of this equation.
Yeah, yes, I am telling the answer.
Okay.
At
Sir, may you please wait for 5 minutes?
okay.
Thank you. Yes, Shahid Bhagat Singh State Technical Campus, Firozpur. Shahid Bhagat Singh, Firozpur.
Sir, excuse me.
Yes, please.
Sir, we are from RVR and JC College of Engineering, sir.
Which college, ma'am?
RVR and JC College of Engineering, Guntur, AP.
Yes, ma'am. Yes, ma'am.
Sir, one small request is we need explanation in English, sir.
Okay, okay, okay.
And solution for this is we got a feasible region.
Okay.
Which is maximized at 10,50, sir.
Okay. And what is the value of objective function?
Z function 1250, sir.
Yes, you are right.
Sir, another small doubt, sir.
Yeah, please, ma'am.
Of all the constraints you have considered earlier,
yeah,
we didn't get any constraint like where the constant term is absent, sir. Like if at all we don't have any constant term.
Sorry, ma'am.
Constant term, sir. If we don't have any constant term, say if the line is passing through origin.
Yeah.
So no such case is considered, sir.
Okay, that we will consider then tomorrow.
Okay, no problem, sir.
Okay.
Yeah.
Okay.
Thank you.
But for that thing also, like we have a constraint, like this is y is equal to x. Okay.
Yes, sir. Yes, sir.
Y is equal to x, and second line is something like this. X minus y is equal to 2.
Yeah, there is a possibility for that, no, sir.
Anything that this is 2, 0 and 0, 2. Okay.
Yes, sir.
So for that, if this equation has this type, we can say y is less than equal to x.
Yeah.
Okay. Or we can say x minus y is less than equal to 0. Just simply say x minus y is less than equal to 0.
Yeah, that is a possibility. No, we are just asking, sir. That case is not considered.
Yes, yes, but I'm just telling you the just example.
Okay.
Okay. So we can put any value of x and y, which is like we put 1, 2. Okay. So 1 minus 2 is less than equal to 0. So is it true or false?
True. Minus 2.
True. But 1, 2 there lies. This is 1 and this is 2. So like here something. Okay.
So solution is towards.
So this is our point. Have you got it or not?
Yes, sir. Yes, sir. Sure.
Okay. And similarly, if we have this portion like this portion, we have like this type. Okay. Have you got, ma'am?
Yeah. We are getting, sir.
So, but we have also constrained that x, y is greater than equal to 0.
Yes, sir.
So we have just this type of portion.
Yes, sir.
Okay. Okay.
Yeah, thank you, sir. Thank
Yeah. Thank you. Yes. Sobha Sari Engineering College.
Yes, sir. The
Yes.
same, sir.
Yes.
1050.
May we have the answers, please?
Yes, sir. 1050. 1050, sir. Optimize solution.
1050.
Yes, sir.
No. What is your objective function? What are your
15y.
What are your corner points?
Starting from origin, sir.
What are your corner points?
Yes, sir. I'm telling from the origin. 0,
Yeah.
0, 0, 60.
Okay.
10, 50, and 20.
Yeah.
0.
Yeah, but I think you should check the value at 10,50.
Yes, sir.
It is 1250.
Sorry, sir.
At 10,50.
Yes, sir.
The value become 1250, not 1050.
Yes, sir. Yes, sir. Calculating mistake, sir. Sorry.
Yeah, okay.
Okay,
So
sir.
now we solve. See. First is 5x plus y is 100. What are the coordinates? 20, 0 and 0, 100. Next is 60, 0 and 0, 60. So what is the feasible reason? This one. Okay, this is point A, this is point B, this is C, and this is 0. What is the coordinate of point B? 10, 50. So answer is 0, 0, 0 is 0. A 0, 60. What is the answer? Yes, please. How much? 900. B 10, 50 is 1250. C 20, 0 is how much, please? 1000. But now you should proceed this model using isoprofit method. Isoprofit method, what we have to do? Yes, Mahavir Swami Institute, Sonipat. Mahavir Institute, Sonipat. Yes, Dr. Sanjay Kumar ji.
माइक ऑफ है आपका, माइक ऑन कर लीजिए.
Hello, sir.
Yes, ma'am. Ma'am, please tell how we can proceed if we have to solve this model using isoprofit method. अगर हमें isoprofit method से करना है तो कैसे करेंगे?
Hello, sir.
Yes, please.
Sir, firstly, we need to take LCM of the objective function.
Yes, 50 and 15.
Yeah.
Yes.
Then, after taking the LCM, we draw parallel lines after our first line that we got taking the LCM.
Yeah.
And we draw that parallel lines up to the point R, so that we find the optimum value.
But here is
point.
not R, here is B.
Yeah, it's B point. It's B point. I took it R.
Okay. Okay, good. Please have a seat. Thank you. So now we, first of all, we take LCM of 50 and 30. 15. 50. What is the LCM of 50 and 50?
150.
150. Okay, but I think 150 is very less value, so we should take second multiple. 50x plus 15y is equal to 150. So what is the coordinates? 3, 10. 3, 10. Okay. Second is 50x, 15y is 300. Coordinates 6, 0 and 0, 20. Why these all are parallel lines? So then what it affects on multiple? See, Bhavan Mahavir Institute, Haryana, Sonipat, Haryana. Bhagwan Mahavir
The same slope. They are
Bhagwan,
having the same slope.
Bhagwan Mahavir Institute.
Yes, sir.
Yes. Why always these lines are parallel?
Because they are having the same slope.
Yes, because these all lines having same slope. What is the slope?
Minus coefficient of y by coefficient of x.
Okay, so we can, because these lines have same slope, so these always are parallel. So next is 50x plus 15y is 450. Coordinates please. 9, 30. Okay, so similarly we have what is our objective? So please tell CT Institute Jalandhar. आप सिटी इंस्टीट्यूट जलंधर ये बताएं कि हम कब तक ये लाइनें ड्रॉ करते रहेंगे? यस, सिटी इंस्टीट्यूट जलंधर. यही बोले मैडम, आवाज नहीं आ रही इनकी. ओके ओके, तो कौन रह गया? यस 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 प्लीज.
सर जब तक ये लास्ट को लीव नहीं कर देगा जो हमारा रीजन था.
कौन सा इंस्टीट्यूट? महावीर है मैम. ओके ओके. पीवीपी सिद्धार्थ इंस्टीट्यूट आंध्र प्रदेश. पीवीपी सिद्धार्थ इंस्टीट्यूट.
Sir, it lies between 1200 and 1350.
My question is that how we can decide until what line we will stop to proceed the lines.
Sir, can you repeat the question, sir?
हम कब तक ये लाइनें बनाते जाएंगे?
Sir, English, sir.
Okay, I am asking that at what step we should stop making these lines.
Sir, it should cross the feasible regions.
Okay, so may you tell the point, please? Which point?
This point, sir. This point.
P point.
Yes, sir, which you are pointing.
Okay, so in this way we can draw these lines, and when we reach this point at B, then we stop writing these lines. Clear?
Yes.
Okay, fine. There is one more question, last question for this session. Minimization problem. This is last question, then you will be free. I will ask from all the centers. So please solve this problem. This is minimization problem. Z is equal to 3x plus 5y. Z is 3x plus 5y minus 2x plus y Yes, please solve this question.
So I have a question.
Yeah, please.
Isotropic method is time consuming.
Yeah.
Why do we go for it? Why not to go for the other one?
We will always go to extreme evaluation method. We never use isoproved cost method. Yeah, definitely. We always, but this is for practice, because there are some courses in which this isoproved method is included. That's why I am telling here. Otherwise, in practical, we never use. So first of all, draw the constraints equations with its feasible region, with its shaded feasible region. आएगा यार but इसमें minimum है ना. See, we have to minimize the objective function, so we will definitely have some. Have you done? Done? Yes, what we have to do here? First of all, what is the equation for minus 2x plus 5z4 coordinates, please? Yes, coordinates for first equation.
Sir, this is Suresh Ganwar University.
Yes.
Can I tell the answer?
Yeah, sure, sir.
The x value will be 5 by 3, y will be 1 by 3.
No, sir. I think this is 8 by 3.
8 by 3.
Yes, Sobha Sare Engineering College, Rajasthan. Shaheed Bhagat Singh Institute.
Sir?
Shaheed Bhagat Singh Firozpur.
Hello, sir?
Shaheed Bhagat Singh Firozpur.
Sir, we are ready with solution, sir.
Yeah, sure.
It's 8/3, 1/3, sir. Optimum height, and it is open polygon.
Okay.
Optimum value, minimum value is 9.7, sir.
9.7 or 6, it's okay, fine. Very good.
Thank you. We are from RVR and JC Guntur, sir.
Sure, man. Thank you. Shaheed Bhagat Singh, Firozpur. Shaheed Bhagat Singh, Firozpur.
So we are trying.
Okay.
Yeah.
You should try. Panipat Institute.
They are also trying to solve this.
-2,0 and 0,4.
हाँ वो उससे करेंगे ना equals to 3 और
for this, which reason 0,0 less than equal to 4? Is it true or false? True. It means this portion will lie. Second is 3,0, 0,3. (0,3). Next is 2,0 and -1,0. Is it okay? So, what is the feasible reason? For this reason? And for this? Okay, so this is the reason. Okay, but we have to tell only minimum, we have to minimize the objective function. So we have only 3 points. Which one? This one, 0,3. And what is the coordinate of this point? This point? This point. 8/3. 8/3. And 1/3. And next is 1 point is more for this calculation. This one. So this is not need here, only this we have to take. 0,3, 8/3, and 1/3. So what is the answer?
-6, sir.
-6, sir.
Sorry?
-6.
-6?
-6 minus.
Which 9.6.
-6 only.
Which institute?
Sobha Sare Engineering College.
Sir, Sobha Sare Engineering College. Yes. At which point you are you are receiving -6 point?
-1/3 and 3.3, sir.
Sorry?
Sir, I am starting from -2 and 0. Extreme point.
No. See, we have to remain just in first quadrant, sir. Are you getting me or not? Yes, Sobha Sari Engineering College.
Hello.
Yes.
Yes, sir.
See, we need not to find the value of objective function at -2, 0 because -2, 0 lies in second quadrant.
Yes, sir.
So, but we have to remain in first quadrant, sir.
Okay, sir.
Because x, y is greater than equal to 0, na?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. Last question.
Okay.
Last question.
0, 3 value is 15. Here is 9.6. 0, 4. 0, 4. 20. Answer is okay. So if we have to solve this equation by isoprof method, so what we have to do first? Take LCM of 3 and 5. What is the LCM? 15. Okay, so to start draw the lines. 3x plus 5 is 15. 3x plus 5 is 30, etc., etc. So till we reach this point. See, in minimum case, important point is in minimization problem, we have to remain nearest to the origin. Important point is in maximization, by using isoprof method, we have to check the line which is farthest from the origin. But during minimization problem, we have to check the line which is nearest to the origin. Okay, so here we have to check this point, this line. Please see here. For minimization, this line is the minimum. This line has the minimum distance from the origin. Okay. If we do this question by isoprof method. Okay. Thank you. If you have any doubt, you can ask. Nodal centers.
No, sir.
If you have any type of doubt, you can ask. Yes, any comment, any query?
No, sir. Thank you and nicely delivered, sir. Thank you so much. So
Okay.
Thank you, sir.
Okay. Yes, RVR College. RVR College, Guntur. Any query, any comment, any suggestion?
Thank you, sir.
Hello, sir.
Yes, ma'am. Yes, ma'am.
Sir, thank you so much for providing all the basics, sir. We have all our we have faculty from all our all the disciplines here, sir. So even they have expressed their thanks, sir. One small request is at least for tomorrow, sir. I mean, since we are from South India, we are not that fluent in following Hindi, sir.
Okay.
So if it is, better presented in English, that is good, sir.
Okay. Okay. Thank you, ma'am. Thank you.
Anyway, thanks for your patience. Thank you, sir.
Okay. Any other college? Any query or comments so that we can end up with session?
Hello, sir. This is from PVP SIT Vijayawada.
Yes.
Sir, one of our madam is having a query.
Yes, ma'am. Please.
Sir, in isotropic method,
Yeah.
so if it is the case of maximization, we have to move farthest to the origin. And if it is the minimization, we have to move nearer to the origin, sir, right?
Yeah, sure, ma'am.
Sir, in the last problem, if we are going 3x plus 5y equal to 15, that is the profit equation.
Which ma'am? Which question?
In this question, if we take the LCM, it is 15. So we use the equation 3x plus 5y equal to 15.
Yes, ma'am. Yes, ma'am.
So if we multiply that with 15, 30, 45, then how it moves towards the origin, sir? it seems it is away from the origin. The points are away from the origin.
Okay, 3x plus 5y is equal to 30 is going beyond the feasible region.
Uh, 3x plus 5. It is not crossing, sir, actually, but it is not nearer to the origin, sir.
Okay, so that's why I told you that isoprofit method is only proved by hit and trail method.
Yes. Okay.
We have to check like you have to check 29, 28, 27, 26 like that way.
Okay, sir.
Because until and unless we reach to point this, because this has very nearest distance from the origin.
Okay.
So till that we have to perform this method using hit and trial values.
Okay. Okay, sir.
But I just told you that how to start with isoprofit method. First take LCM and then take multiples of that values.
Okay, sir. Thank you, sir.
Thank you, ma'am. Thank you. Okay, thank you so much. Thank you.